would invite Professor Maiti to introduce Professor Allen. Professor Maiti.
Hello. 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 Good evening, Professor Allen. Very good evening. Okay, very good evening to everyone present online as well as offline. It is my pleasure to introduce Professor Dr. Theodore T. Allen, who is Professor of Integrated Systems Engineering and Computer Science Engineering of Ohio State University. Dr. Allen joined Ohio State University in September 1996, bringing extensive experience from his tenure as a full-time intern at Ford Motor Company. His career has been dedicated to designing and implementing optimization, quality assurance, and digital trust solutions for manufacturers, healthcare organizations, and supply chain management. He serves as the simulation area editor for Computer and Industrial Engineering Journal and as an associate editor of the Journal of Manufacturing Systems. Notable achievements of Professor Dr. Theodore T. Allen include his collaboration with DHL Supply Chain, a finalist in the 2023 Informs Edelman Award, credited with saving over $100 million in fuel and outsourcing costs. His work on public awareness and education with Fact Spread is a finalist for the 2024 Informs Innovative Application in Analytics Award, potentially impacting millions by promoting vaccination. Additionally, his research on anti-fragility in cyber security received the 2022 Department of Defense University Consortium for Cyber Security Award for achieving mission resilience and anti-fragility. Dr. Allen has also received numerous Best Paper Awards and 6 teaching awards. In addition to his involvement with CDME, he chairs the Integrated Systems Engineering Prize Committee, serves as the faculty director of Industrial Cybersecurity for the Center for Design and Manufacturing Excellence, and contributes as a member of the University Information Security and Privacy Advisory Board. He also holds the position of Vice President of Communications for the Informs Public Sector's Operations Research Section. With this, we welcome Dr. Professor Theodore T. Allen for his keynote speech, the first one of today's morning here, but evening or in night with Theodore Allen's place, Ohio State University. Professor Allen, hearty welcome to you. Please start your keynote.
Thank you very much, Professor Maiti. I appreciate your introduction. Today, I'm going to talk about leveraging analytics and optimization for real-world impact and case studies, the 2 case studies that Professor Maiti mentioned in my bio, working with DHL and the one that we did working on public health. There's a lot of people who help to support all the research that we're doing, and we're doing it, as Professor Maiti mentioned, with these 2 departments at OSU in my lab. And I'm working with a lot of people. It's a really nice environment. There's a lot of smart people who have become my friends, I'd say, and we work together regularly. We have a lot of sponsors, which is really nice. One of the great things about working in America is that there is a lot of support for grant. It's not that hard to get grant money sometimes. And then, of course, our terrific students. And this gentleman in the middle here that I've marked in red, he's involved in the second of the two case studies. He's very important. And he has some Bengali heritage, which might be interesting to people. And so the first problem relates to the problem faced by DHL supply chain. They are the world's largest third-party logistics. They run supply chains for other companies. So they have to bid and say, okay, give us $7 million and we will run your supply chain for this period of time. And to do that, to win those bids, they have to solve very large problems and for routing and problems basically of this type. So it isn't really their choice. Actually, the customers run these competitions, and so they have to try and win them. And the competitions don't have 100 deliveries in them. They have some of them are approaching 1 million deliveries. And so math programming is not going to cut it. And they also have outsourcing, and DHL has their own fleet of vehicles, but then at any given time they need to use other fourth-party logistics companies, and then they also have to decide how many electric vehicles to purchase for each contract. And then the second problem that we're going to talk about is, and really there's only two, this is a problem where around 300,000 people lost their lives in America, the United States, because of misinformation. And that's estimated by just looking at excess deaths in different counties. And I didn't do that estimate. That's a famous estimate. And we all know that this intuitively has to do with the fragmented media ecosystem causing loss of faith in democracy and facts. But vaccines did actually save around 2 million lives. And in fact, our project where we convinced people to get vaccinated, you can see when we ran our ads in late 2021 and early 2022, the vaccination rate in the places where we ran the ads had a big spike right after we ran them. And so we'll talk more about that. So about me, I already basically talked about me a lot, but I'll talk a little bit more about me. And then we'll talk about each problem and then impacts in the future. So this is all faculty, I'm sure, at a great university like IIT Kharagpur and also Ohio State University and many other places. We have to balance teaching and trying to get into prestige journals and trying to get citations and prestige journals are important because they're the place that gives us high-level feedback, but it's often very critical and kind of slow. And then we also have to fund our research. That's particularly important at some of the universities I'm familiar with. And then I'm hardly the first professor who tries to have real-world impacts. It's a long history, but I do feel like there's a growing trend, at least in the United States, where we're starting to expect professors to be leaders and actually change the world, not like it through journals, but fairly directly. And there's a great leader named Professor Dmitry Bertsimas at MIT, and he's sort of trying to spur us all on. And there's also the challenge of, trying to deliver technologies that are truly transformative, like large language models, quantum computing, and so, as I'm getting older, I'm trying to shoot for the stars and try to deliver things that might be mentionable in a breath along with those amazing transformative technologies. And today I'm going to talk about this idea of benign double analytics that I think is the best idea I've had. And I think that basically the most important thing I've probably learned in my career in terms of trying to generate real-world impacts is to view the real-world impacts as a critical part of research topic selection. That a lot of faculty, understandably, are struggling to do teaching well in prestige journals and the other things are hard and they haven't gotten to them. But for a lot of us, we start realizing that our topic selection is not going to be very good unless we are deeply involved in the business of the world. And so I'm not saying everybody should do it that way, but I know it's important for me. And I've heard Professor, the great George Box seem to be saying similar things. And then also we have to try to expect our responsibility, accept some kind of responsibility as leaders. And of course, we should be very humble because professors can be remarkably ignorant on many subjects. I know that's true for me. I'm not saying all. So these are things to balance. These are things I think about, and maybe they inspire you. So the first challenge relates to the DHL. The second challenge relates to the fact spread and the vaccination. So for DHL, there were actually multiple sub-problems, and I'm just going to talk about the first two right now. So when DHL is trying to bid on business, it has to think about outsourcing, as I mentioned, because the fleet is finite. And then they also have to think about using electric vehicles, because electric vehicles can save a lot of money. I mean, of course, they're great for the environment, but if you use them for certain roles in a routing pattern, particularly city roles, they can save a lot of money. And to solve this, we had to do very large scale, near optimal meta-heuristic based on symbiotic ant colonies and parallel processing in Python. And that was a big problem. And we had to basically benefit from all the smart ideas that DHL had developed over the years. We're just contributing part of it. They already came up with the idea of cherry picking the online demand, and to some extent that's already built into the trials. And then identifying fleet availability, and then entering data inputs, and then running our meta-heuristic. Then, if it's good, do the bid. Otherwise, do the change, and do it again. So, but for the fact spread, we basically think that maybe one of the biggest problems in the world has to do with democracy having trouble. And that could be an issue across in other countries, not just America. And we sometimes get frustrated that our public seems to be gullible and has different problems. And so I was inspired by various people, and we'll talk a little bit about them, to invent what I call benign double data analytics. And basically what that means is we're going to identify the message and issue and make a graph. And that's sort of one analytics. And then we're going to pick the population and metric, how we're going to measure this. And then we're going to develop ads. And then we're going to run the ads and measure the effects. And analytics is involved in both the first and second of those stages. And so that's why it's double analytics. Because there's the analytics you show the end user, and then there's the analytics that you use to direct the information. And it is true that these are applied projects where we've had some real success in influencing the world, but we're also trying to integrate them into the broader situation and scholarship in the journals that we're familiar with and that we tend to use. And so actually the work I'm presenting today is actually in all these articles that are already written and almost all published. And that's one thing you should know. There's a great journal, I think, called the Informed Journal of Applied Analytics. I think that, this has been going on, it used to be called Interfaces. It's been going on for a long time and trying to say, if you have an actual impact, we're going to make some allowances and try and share that information. And so actually that's where this is, and that's hopefully where this will be too. So back to the first one for the DHL project. I'll talk a little bit about the motivation and methodology and the literature as we saw it. So this is the software that my student, Ibo Dang, developed as part of his dissertation at the Ohio State University. They call it D3TO at DHL, and many people use it. About 30 people use it sometimes. One of the big functions, the original function, was to support this bidding, but now it's also involved in improving existing projects. And it's also spreading all around the world. So the problem, as I mentioned earlier, is very large. I mean, we really do solve problems approaching 1 million deliveries. And there is outsourcing, which makes it even more complicated. So you have basically, this is like the cost of running the trucks yourself, but then this is the cost if you choose the outsourcing mode, because you have to pay maybe UPS. And then there's the cost of electrification. It actually changes because the formulation changes because you have to stop to do charging, and also the cost structure changes. And then pool points are also important because if you are outsourcing, you have to take the routes that you're going to outsource and you bring them to a place and you leave them there. Then that's where the fourth party comes and picks them up. And then for some of the round trips, if you schedule it and you see there's some really round trips that might go past a single depot, then you want to fill them up on the way back. So trying to solve all four of these considerations, all five of these considerations simultaneously has not been possible. And so we actually are solving them as very large integer programs in a sequential process. So just to look at the basic idea of a milk run, this may be familiar to a lot of people. A single truck has to hit these deliveries in time windows. So there may be the yellow time window and the blue and the red, and this truck has got to figure out a way to bring to each customer the goods it has within those windows. And this problem was found to be NP hard a long time ago, and there was some progress on exact methods, and we do use exact methods to test our meta-heuristics. And then there was some success with ant colony search, which was very helpful to us in a very large computational comparison. And then we just took those methods and made it some common sense changes, including parallelization, and that was our first approach. And then we realized that we could do better by designing a new type of ant colony search. And then we put the full system to solve all five of the considerations I mentioned. And this is now potentially influencing other organizations as well. So basically, we're still solving this problem as a single period deterministic optimization problem. And that's partly because that's how the trials are designed by the customers. And this shows a depot and routes reaching out from the depot to the customers, and there's potential for having some of the deliveries be designated as outsourced deliveries. And then also the challenge of needing to go to rechargers if you're using an electric vehicle. So basically, this was all the idea of our colleagues at DHL, that we would divide this into different periods and solve first, okay, let's generate a sort of rough overall schedule with outsourcing. Okay, let's take the part that DHL is supposed to deliver. Let's run on that and run on that again, and we'll decide which ones are, how many cart trucks we need, and then also how many electric vehicles. Okay, let's take that. The ones that are outsourced, we'll think, okay, where's the best pool point place to leave them, and maybe tune the routes. And then we'll also, for the long trips and all this whole plan, we'll fill them up on the backhaul. So basically, the red-black ant colony method, well, it uses two types of ants, and we always think of them in terms of the DHL carriers and usually UPS. And in fact, UPS probably has had financial trouble because of this, or partly because of this project. That's another thing about changing the real world. because we basically economized and used them less. And part of what we learned, and really this was a key insight, and I mean, I had sort of a rough idea, and you both made it real, that it's important to embed rigorous methods for the subproblems because the ant colony is very noisy, and if you're trying to do the outsourcing together, it doesn't work very well unless you clean up the routes with dynamic programming and part of the iteration. So we have the algorithm, we specified it. There's a patent pending for this work. I don't know how seriously DHL will pursue this. And they've adapted methods from other works to solve different parts of the routing challenges. And we also, of course, tested this with optimal solutions and found pretty nice exact results. I mean, pretty good results for the problems, the small instances you could solve. And we also tested it against meta-heuristics, and we basically think that in the future we can combine those problems better, just like we combine outsourcing and routing. We could maybe add more. And we could also address uncertainties, although that is not obviously important for the bidding as it is now. So that was the first project. The second project is also exciting to me. It's something we did more recently. As I mentioned, I'm coining the term actually today because I don't think I've ever presented this term in a public presentation till today. I love this term, benign double analytics. And basically the idea is that the single analytics is you show a graph, you prepare a graph and show it to people. So here's why you should get vaccinated. Your chance of dying with and without. This is one of the graphs here. That maybe a better looking graph will be this example. Your chance of dying without vaccination as a function of your age. And here, fact check is yourself. So that's analytics right there. And it's helpful to the end user. Maybe some of them don't believe it, but I think there's very compelling evidence. It's clearly good for them. And then it's double analytics because when you show information to people, they don't always do what you want. Some of them actually do the exact opposite of what you want. But then you use analytics to then target more of the ones, to see the patterns, and then target the ones that it does work for. And so that's the second level of analytics. And, I think, again, it also has to be clearly good for us. And, of course, I learned this idea. I came up with the idea of doing this along with Antor and Long by watching Fareed Zakaria at GPS, who has a great show on CNN, if you ever get a chance to watch it. I love that show. And then we ran surveys and developed storyboards and did the campaigns. And then we had to change the whole thing because in between the campaign 1 and campaign 2, we had a different variant and the whole situation sort of changed. So we did all that in about 6 months. And the ads are very cheap, actually. And I bet you they'd be even cheaper if we ran them in India. But basically we found in our preliminary analysis that the information can truly hurt some demographic groups, or might truly hurt demographic groups from studying the effects of college degrees on different groups. And actually for certain minority groups, the more college educated they are, the less vaccinated they are. So we designed an approach where we would test in the first period, see how it works, do a big experiment, and then do a second period where we learned. And we also, in addition to trying to help with vaccination and helping people not die from disease, there's also the benefit potentially of just teaching people how to do fact checking, or that it's important to do fact checking and about analytics. And so as part of our double analytics, we had to cluster all the counties. The United States is organized, each state has counties and they're different sizes, so it's important to group them into the same kind of size so that and the homogeneous groups are about the same size so that you'll get equal variance assumption, a reasonable equal variance assumption for your regression model. So we did clustering, and then we did optimal design of experiments to decide which clusters we would give different treatments. And so this actually shows the design of did and some of the vaccination data that we got from the CDC in the United States. And then they show the clusters that we got from the optimization. And so then this is a regression model we got from the designed experiment after we measured it as effect on vaccinations. And we basically found that, you know, our choice of using keywords, for example, drove the vaccination rate up in the counties. If we use keywords in our Instagram or in our YouTube ads, we could drive the vaccination up by something like I don't know, 5%, 6%. And so we did that, and we basically, we basically proved in the first case, we were able to literally use DHL's system that they already used that they have approved in their contracts to prove our savings. So in a way, the savings doesn't actually include the increase in the revenues that happened during the period. The revenues have gone up by several $billion. So over the last 10 years. And so this is only part of that story, actually. But our savings only includes these direct amounts that were measured. And then for this project, we used this causal impact analysis to basically, you saw that uptick in target population. This is a common use for a common way of estimating the effect of advertising. I think there's maybe some issues with it, but if we take it at face value, it indicates that we got 2.2 million people vaccinated by reaching about 1 million people. So there was sort of a contagion of information. We reached 1 million people about 3 times, over 1 million. And then that would mean that we saved 18,000 lives, which would mean that we saved 18,000 lives. That's less than $10 a life, making this arguably one of the most cost-effective charities in the world. So that would mean that sharing information can be the most cost-effective charity in the world in certain situations. So basically, for future work, and this is the last slide, and thanks for listening, we're investigating deep reinforcement learning for solving similar types of integer programs with Goodwill and NetJets projects that we have now. And we're trying to get a better interaction so you don't have to wait for an hour and maybe find out that you mistyped the inputs. And we would like to get near instant feedback so that people can basically get optimization support while they're doing replanning. And that's not just our idea, I mean, that's actually a very big trend that's happening in the literature, you're probably aware of. But we're trying to contribute to that. And then for double benign analytics, we're trying to create clearer evidence. And basically the experimental design did a pretty good job of giving us good accuracy and low variance inflation factors, but we'd like a clear evidence control versus treatment. It wasn't designed for that purpose. So our next run, I'd like to illustrate a better design that takes multiple criteria into account. So thank you very much for listening. I really do appreciate it, and hope you're having a good morning. If there are any questions, I'd be happy to try and answer them.
So any questions for Dr. Allen?
Good evening, Dr. Allen. I just have one small question. Initially, you talked about the potential of using large language models. So how do you envisage incorporating LLMs into your future work?
Well, Well, obviously, large language models are extremely important and quite impressive in some ways. We're trying to do two things. We're trying to study how design of experiments can help improve the sort of accuracy of large language models on different tests. But we're also more interested in the interaction between operations research models and large language models. And so we're trying to get many different parts of it. Of course, we all know that large language models hallucinate, and they're not necessarily particularly trustworthy for a lot of activities yet. And so safety of them is important, even practically, but of course also important for various big picture reasons. So we're wondering if we could help participate using the kind of tricks and tools that we know about research, simulation, experiments, programming, to basically help safety and improving quality. Does that answer your question?
Any other question?
Thank you, sir. This was a great presentation. In one line, you have mentioned that using Gurobi for the smaller instances, you have solved within 1% optimality gap. So, can I ask you, like, what is the size of your smaller instances? Like, how many nodes and what are the variables? How many number of variables you have considered? Like, Gurobi is a very good optimizer, and for the smaller instance, it can be solved with a 0% of optimality gap also. So that's my question actually.
Yeah, so I mean that's basically our standard process that even Professor Shiv Roy-Chowdhury used in his dissertation. For every problem that we solve with meta-heuristics, we dial it down to solve the same problem with rigorous methods. Actually, with this, one of the people who was on the call, Gurobi is fine to solve the problem. We don't need meta-heuristics. So sometimes the instances are big enough. But in the DHL problem, it really is true that they at least needed something like 15,000, maybe 20,000 from each depot. And, Gurobi, we weren't able to solve any problems bigger than 200.
Yes.
And so, but we still use Gurobi sometimes and, as a heuristic, don't run it till the end. So we might run it for an hour or run it for a day and then quote the time from that. But basically, in the DHL problem, that was a situation. I think both if you do sequence dependent scheduling, if you do routing, we found Gurobi is not really ready for the problems that the people we were working with need. But if you do assignment problems, Gurobi is very good. Does that help?
Yes.
Hello, this is Professor Maiti, Dr. Allen. Thank you for your excellent presentation. Particularly, you have combined the optimization as well as data analytics in probably multi-level modeling or in methodology, different stages, different phases in the methodology development point of view. Am I audible to you clearly? No.
I'm sorry, yeah, there's some kind of problem with the microphone. Sorry about that.
Yes. Is it okay? Audible now?
Yeah, it's better now.
Better. So thank you for your excellent presentation today, particularly combining the two different aspects of that is, one is optimization, another one is data analytics. And what I understood that you have used optimization at the beginning and then data analytics, means from the methodological perspective you have made lot of innovation. What are the key challenges, one or two challenges, if you highlight to us, that in the integration process, when we are integrating optimization and analytics together, what are the key challenges from methodology development point of view, or that I can say integrating two techniques, two different types of techniques point of view? Thank you.
I hear. I think I understand your question. I couldn't. I apologize. I couldn't hear the whole thing. But basically, I do think a big motivation for research of our lab for recent has been when you combine regression modeling or some kind of statistical model with optimization, then you have the posterior distribution from the regression model, and then that's a certain kind of uncertainty. It's a special kind of uncertainty because it can be reduced by collecting more data. And so that relationship within the final decision problem, or when you lead to decision, is a very important subject, I think, and it's a big motivator and excitement for my research. And when we were doing this, when we were doing the work with trying to influence people with ads, and I really think that's a very important subject for probably in India as well, because we both have open societies, generally pretty open societies, and we also have a lot of misinformation situations. So designing experiments to support understanding how different populations receive information is an important subject. And then trying to think, okay, now I have this regression model that can give some predictive ability, and I want to support decision making, but then I also want to deal with my uncertainty of various types, parametric uncertainty, which could be reduced by gathering more data, or just intrinsic uncertainty, and that you can't reduce. And so, I think that's a very important subject. I think that's partly what makes the kind of work that we do important, because there's still unsolved issues I see there. And not just me, I mean, that's a big subject that a lot of people are working on. I hope that answers. Does that answer your question?
Thank you, Professor Lenny. Yes, we are extremely happy.
Oh, now I can't hear it all.
The microphone's off. The microphone is
Okay.
off.
Yeah, it is. Oh no. I hear something now.
Yeah. Okay. So thank you, Dr. Allen, and I think most of you know, but Professor Allen has been my PhD supervisor, and he is one of the nicest supervisor that you can ask for. So I hope I do the same kind, bring the same kind of legacy for my own scholars. And thank you so much for your time. And there are some more presentations by Dr. Allen and his team tomorrow at 9 a.m. So if you are interested, please join. So thank you, Dr. Allen, and wish you all the best. Thanks.
Me too. Bye, Dr. Wojciechowski.
Yeah. So our next presentation is by Mr. Anshuman Bhattacharya. He is the AVP of Adani AI, and Professor Anand Abraham will introduce Professor Bhattacharya. So just wait a minute. Yeah, but let him come first. He was here. Just wait a minute. Let him come.
Uh, our second keynote speaker for today is Sri Anshuman Bhattacharya. Sri Anshuman Bhattacharya is an entrepreneur and a professional in the area of AI and machine learning with about 2 decades of success. He was the founder of CBI Analytics, which is now an Adani Group company after the acquisition in December 2022. He has an extensive experience in consulting and providing solutions to Fortune 200 and top Indian and APAC enterprises. He is a pioneer in enabling the machine learning journeys for SMBs across the world. Mr. Bhattacharya is an avid technology and cloud enthusiast, always thriving for client success using advanced data science and machine learning solutions. He believes that the rate of data consumption is much lesser than the rate of data generation, and AI ML technology can help grow this rate of consumption and thus help generating real-time smart actionable insights to make the world more efficient. We are extremely glad to have you, sir. Over to you. Hearty welcome, sir.
Hello. Uh, Firstly, thank you IIT Kharagpur and the Department of Industrial and Systems Engineering for inviting me in this auspicious conference and inviting me for delivering a keynote lecture. I'm highly grateful to the institute, and it's an honor to me. Being a non-academic, who has left college and universities more than 20 years ago, coming back to any institute is always a sense of pride. And being in IIT Kharagpur, you can imagine that it's a pinnacle of that pride. So I am again thanking you all. I'll talk about some of the applications of analytics and AI and machine learning in the business or industry, how in real life these methodologies and technologies and the science that we learn are applied and solve business problems. A brief about myself, but just because I have been introduced, I'll skip that. By training, I am an econometrician. I did my master's and worked towards a PhD in econometrics with specialization in econometrics. And in the last 20 years of my career, I have been dabbling with mostly various types of econometric models, implementing them. However, you can imagine that as you grow up in the corporate ladder, working hands-on, opportunities of working hands-on become less, and you are more focused on other aspects of business. But still, I tried to keep in touch with this because I am passionate about solving business problems using various types of models, etc. So, so let us see, how much I can add value to your already established set of knowledge. This is how I have organized today's content. Is that first we'll talk about certain challenges which are more or less common across industries, and how different businesses measure success of different aspects of their business, of the industry, and how to achieve the above. Then we'll talk briefly about recommendation engine. I'll try not to go much deeper into the technologies of recommendation engine, but where it is used, how it is used, and how it benefits. That would be the objective. And after that, I'll go into a more detailed case study where we'll see some type of models, how we assemble multiple models or multiple methodologies to solve a business problem, and what are the results we can get out of that. And maybe after that, if time permits, I'll talk about another small case study. So, if you look at any business, any industry, these are the main functions of that. It starts with production. Sorry, there is a spelling mistake. But it starts with product. What product or service we want to sell, that's where a business starts. Then the production of that, how do we produce, manufacture that. Then acquisition of customers, we get how to get those customers. Then the sales process. Then the sales process is supported by marketing, because until and unless you market, let your people, let your customers know about your solutions or products, you will not be successful. And finally, there is always a gap between the sales happen and your production. So, the in between, where the quantity of product you are storing, that is inventory, and how you manage inventory. Right, inventory management is one of the biggest challenge in many of the businesses, because inventory is nothing but money. Some of your money is lying idle in a warehouse. How to optimize that? In fact, the case study I'll go in deep is primarily about how to optimize inventory. And this inventory not necessarily in a customer business, it could be anywhere. Like say you people are from industrial and systems engineering, so you are working there, you say you are fabricating some machinery, and every machinery requires, number one, a set of parts. It also requires certain raw materials, and then there is your finished goods. So, at every stage there is an inventory. If you want to fabricate say this pointer, laser pointer, there are probably maybe 100 parts inside that, and you have to make sure that all the parts are available when the fabrication line is running. But different parts are coming from different sources, probably different countries. How you manage that? And then once this is ready, and you have to sell it all through the world, and all through the world there are so many stores. Where do you keep it? How much quantity you keep it, so that at the time of sale this is available. So, you have both problems of inventory management at both sides, at your supply chain side, where you are manufacturing, procuring raw materials, procuring parts and manufacturing, as well as when you are selling. So, inventory is a very important aspect of any business. Now, some of the key performance indicators that we believe, I mean it has been established over a period in sales. What is most important, one of the is the channel performance. I have a retail channel, I have an e-commerce channel, and the retail channel also may have many stores, etc., many retail chains. So, that is my channel performance, and of course, the volume, revenue, number of units, month on month sales, last year same month sales, last year same quarter sales, because a lot of products are, you know, seasonal in nature. So, if you are selling sweaters, you will sell in the month of November, December and January, right? You will not sell in February. So, there is no point comparing a February sales with a January sales, because January sales will always be higher. It is better to compare the February sales of the last year's February sales, because last year February was also out of winter. So, that is why these metrics, these time metrics are important in marketing activities, channels, where you are say you are active in television, print, radio, digital. These are your activities and channels, how you are performing over there. And a very important metric is that spend and ROI, how much money you are putting in, and for that how much sale you are generating, or any other metric you are generating, right? Because marketing is kind of a ocean where no amount of money is sufficient, but you somewhere you have to put a cap, put a limit, and see what is the ROI I am getting, or is the right marketing channel we are using. Effectiveness, efficacy, like how much marketing actually is good, and beyond which there may not be any value. Similarly, in product and inventory, already spoken about inventory. New product performance, when you launch a new product, how it is performing compared to the established products. And you know, in this today's world, almost every day new products or new of the same usage, same purpose, new products are coming. So, this is today, this is a mouse which is a wireless mouse. Few years back there was wired mouse, and even in wireless mouse also various innovations are coming up. The mouses are becoming small, they are using lesser power, they are more ergonomic. So every quarter you will see a new variety of mouse is coming. How it is performing, gaining the market versus the other type of mouse would be an interesting metric. And you can read through this in manufacturing, the raw material supply, quality of raw materials. You are producing something but the quality is not good. Say I am producing this water, mineral water, but the source of water is not proper, then my production will be hampered. Maybe I have to put more agents etc. inside that to make it potable, and still there could be problems where the customers will be unhappy. I mean, similarly in the customers, how your customer base is growing, which part of the world they are growing, are they coming back to you? I mean, are they coming back to you? So today I buy a Bisleri bottle and tomorrow I buy an Aquafina bottle. That means I have a Bisleri has lost one customer. So all these metrics are important. And why I am talking about this is that when we do analytics or AI or machine learning, our objective is to optimize or maximize or minimize any of these metrics. Right? The objective of analytics is always to optimize any of these, maybe one or two metrics. Every model, every solution we build is focused towards one or two of such metrics, and that's why various types of use cases comes up. So how to achieve this? This is a very standard process, or you can say that over some years of my experience, I have seen that this is how we tackle a problem or approach a problem. So first question, ask, what is the problem? Is my inventory growing up is a problem, or I am having no inventory is a problem, or maybe both. In some cases I have high inventory of some parts, in some other parts are not available. So in both the cases my production, I am not able to maintain my production schedule. Then prepare, okay, if this is the problem, then what are the relevant data? Get the data from various sources. We have, many of the time you will hear that many of the business will tell you, no, we do not have data, how to work on that. And in my experience I can tell that this is a myth. Most of the time this is a myth. Data, many of the time data resides, but we are not looking at the right place. Then the process, okay, now process the data, you get data, and sometimes you get data from various sources which are not really ready for any kind of analysis. Say I am talking about inventory and raw material procurement. So inventory means how much of raw material I have procured. These data probably lies with the procurement department of the company. And how the procurement department keep the data? They keep it in the ERP. So data is nothing but how much purchase orders they have given to the vendors, when the vendor has supplied, and where it is stored. These are the three major facts we need to know. Say this has 10 parts, and there are, say, for the simplicity I assume that 10 parts are supplied by 10 different vendors, and now 10 different vendors, I have to issue a purchase order to them so that they will supply me that. Now there is a gap. So today if I issue a purchase order, they probably will supply me the material after 1 month, and someone will say, provide it after 3 months. So if I go back with last 3-4 years of all the purchase orders, I will know how much order has been placed. But world is not perfect. It does not mean that because you have placed an order you will get it, right? So then we have to check how much of that purchase order quantity they have supplied, and when they have supplied, and where they have supplied. So that probably is with your warehousing team. The procurement team's job has been probably completed when the PO has been issued and the bill has come to them for payment, but the actual product has gone into the warehouse. And then the next step is the usage of that inventory. Okay, in my store this product has come 100 units. The production is happening there. How much my production is drawing from these inventory, this is another data. So this is how you combine various data from different departments. And that is why if you talk to the procurement guy, he will talk that I don't have data about production. but then you have to be intelligent enough to go to the production department and ask how, when and where you have drawn from that inventory. So this is how we approach a problem and prepare our data. And then of course our analysis of the data, finding patterns, to start with do the very basic analysis, whether the amount of production I have done and my inventory for all the material are commensurate. Sometimes you will see that one material has been supplied in full, some or excess, some material has been supplied less, and all this. Then share these findings with your audience. In this case your audience is production manager and the procurement manager. Then from there you create the strategy. Now the production manager knows that if I have to produce this, I need to place an order with my procurement 4 months earlier. Earlier I was doing 3 months earlier, that's why my turnaround time was high, and at the time of production I was running out of raw materials. So very simple example is like that. So this is a process you can follow to solve any problem. I have given you an example of inventory. Think of any other business problem, and probably this 6-step process will guide you how to solve that problem. Okay. Types of analytics, I'm sure many of you would know that, but just reiterating. So there are 4 types of analytics work we do. First is we call descriptive, which is nothing but describing the data, what has happened, primarily in a hindsight, what has happened, what are the anomalies we have seen, what are the peak and troughs we have seen, and what are the gaps. And you can always combine my inventory to my procurement to my production, and what are the gaps. Simple questions like how long it takes from a procurement to receiving the order supply of the raw materials. And for different products, different raw materials, it will have different numbers. The production may ask how much ahead I should tell the procurement that I need this product, and for different raw materials that could be a different number. So this is my descriptive. Next is diagnosis. So what went wrong? Your production said that I could not achieve my production goal because some of the raw materials are not available. So then you know, this particular raw material was not available. If this is not available, then what is the reason? Where the orders were placed in time. If the orders were placed in time, whether that has been supplied in time. Now there we use 2 measure over there, SIFOT and DIFOT. SIFOT is supplied in full on time, SIFOT, right? So whether it has been supplied on time, a metric, another metric is in full. Maybe I have given you 100 order, but you have given me only 80. 20 is said, we'll give you later. So SIFOT is a very important metric in inventory management. And the DIFOT is another, because sometimes what happens, that who is supplying you, he is also using a logistics service, a shipment service, because he also doesn't have a trucking facility. So delivered in full and on time. So he may have produced it, shipped it, but maybe the trucker were delayed by 3 days for whatever reason. So these SIFOT and DIFOT are the type of metrics we use in inventory management, supply chain management. Next is predictive. If this is the case, now I know there is a chance that every rainy season the truckers normally delayed by 2 days of the weather condition or the road condition. So that is my prediction. So next time I am going to order, and I know that if this is the supply would be in rainy season, I better order it 3 days in advance, another 3 days in advance, so that this situation that might happen, and I have seen this happening in last several years in various cases, that can be handled. That is my predictive part of it. And prescriptive, prescriptive is like what I should do in different situations. What if I have to increase my production by 2 times? So then should I use the same vendors, or should I add more vendors for a supply of raw materials or supply of parts? So those are my prescriptive analytics output. Now I quickly talk about something which is very common these days, I am sure we all heard of it or sometimes have been party to it, is recommendation engine, right? And what is a recommendation engine? Anyone knows about what is a recommendation engine? Okay, yeah, of course, some people will definitely know. Now, recommendation engine, whether knowingly or unknowingly, we have been bombarded by this. We go to Amazon, look for a product, and there is another set of recommendation at the below. People who bought this also bought that, or another row, products similar to this. So these are basically recommendations coming to you when you are searching for something. Maybe you are searching for this Bluetooth mouse, and you can see options of other Bluetooth mouse, or you can see relevant products. Maybe the next product it is showing is a Bluetooth headphone, right? And we have all seen that everywhere, not only in buying product. You go to Netflix, I am not sure most of you people probably living in hostels, so the Netflix are allowed or not, but if you watch Netflix, you will see that the moment you search for a movie or a series, another set of recommendation comes in. And most importantly, you people will always see that these recommendations are very close, right? These are not irrelevant, they are very relevant, and many of the time you actually go for it. You started watching this movie, after watching another recommendation came, you also start to watch that movie. That happens, and that's how Netflix actually, I mean, you will see people tell that I am hooked to Netflix, but they rarely search. The moment they open, based on their personalities, their previous content usage, a set of comes, and automatically they get hooked to that. Netflix once said that 70% of their content watch is actually coming from recommendation. That means the viewer did not come to watch that program. Just because it is recommended to him or her, he started watching that program. And it happens with all of us who have ever used Netflix or any similar platform, not only Netflix. I am giving an example of Netflix because they are the pioneers of these things. You can Google it. In 2006, Netflix created an open context. Kaggle was not there, but it was like a Kaggle context, that they have opened up a database of some 100,000 movies and probably 100,000, sorry, say maybe 1 million users and 100,000 movies, and who has watched that. That connect, right? The database that person A has watched movies ABC, person Y has watched movies B, C, D, like that. This database was there. They opened up a challenge and they said, we have a recommendation engine. Anyone who can beat that recommendation engine and give better recommendation, they would get some $4 million or $3 million, I forgot. Interesting story, and you'll find that then there was a time for that. When they opened up the database, given the problem, and then this is say next 2 months or 60 days was the time, and there was a cut-off date. Many people tried, and I was a young analyst during that time. We also formed a team and tried. We get somewhere around 85 or 84% accuracy, but the team who owned, and the Netflix owned recommendation was about 88 or say 90% accuracy. The team who owned, they probably did a 94% accuracy. There was another team who did 95% accuracy, but they submitted their solution after the cutoff time, some 20 minutes after the cutoff time. So that is a huge case study, and you can Google it and find it out. I remember because I worked on that, and during that time, not many of the current machine learning techniques were available, at least was not known to me. We tried some common methods. But anyway, that was an interesting thing. So this is how the recommendation engines have been popular. Very simple example I have given over here. See, there are two persons, and we have written similar, not same. Why similar? Both of them male, young, athletic, right? What is not similar? One person is a runner, another person is a cyclist. So there are some commonalities, some differences. Now this person has bought pizza and salad and also bought, say, carbonated soft drinks, CSD. This person also bought pizza and salad, but just because there are a lot of similarities both in terms of their characteristics as well as the products they have purchased, I can recommend what he did not buy. So I can recommend this to this person. Very simple example, and we can find out. You will see that you go to Amazon, try to read a book, it gives a very relevant books, right? So this is the recommendation engine, is the rank that, now see, there could be many things. This person did not buy only these 3 things, he probably have bought another 20 things. This person also has probably bought another 10 things. So now which product I should show? That is not the recommendation, but the ranking of the recommendation, that is important. What is coming up as the top option? You know that if I am searching in a mobile, I can see only 3-4 products. So how I am ranking that product for a new customer is, that is more important. That's why it is how I am ranking all this, ranks the top products that a particular customer would be interested. That means if I am giving you a movie recommendation of, say, Shawshank Redemption, and say recommendation could be 5 movies, but which one I am putting at the top, that has the highest likelihood of being watched, correct? So this is how the recommendation, this is what a recommendation engine is. And I have written down what kind of data are used. Of course, the psychodemography, like this is an athlete, and all these transactions, what the person have purchased. And not only transactions, sometimes you did not transact, but you have searched for it. The good part with the today's digital world is that we have the record of things which you have not purchased, but you have seen that page, visited that product, maybe tried that product, gone deeper into. So you know, if you look at every every web app, first there is a very high level listing of product, then you click, then you go to the for more detail, then you again click, you go to the very, you know, in depth detail. So that means as for a product, as you go deeper, double click, single click, double click, that tells that you are more interested in that product. So that is what the interest is. And the product attributes. In the next slide I will tell you how the product attributes are used. Pricing is very important, and that is why you will see that if you are searching for a book, you sometimes see the option of paperback first and the hardcover later. For some other person, the same book, he will see the hardcover earlier and the later paperback later. Normally paperbacks are cheaper, but if I know that this person has a higher disposable income or higher capacity to pay, I would put the hardcover over there, so that my revenue increases. Web search that already spoken, social media data, you have seen that now. You have searched for something and in the next moment you see the ad of the same product in Facebook. So these are all connected. Okay, 2 concepts I wanted to share of cross sell and upsell. Upsell is that, say I know that you are interested in computer or laptops, how do I sell a higher price product to you? From an i3 machine, say, to an i5 or i7 machine, or say a better gaming machine. A cross sell is that I know that you are interested in product A, but there are associated products which I can sell. So if you are buying a computer, maybe a cross sell could be a mouse or a gaming console or a headphone, something like that. So these are the examples we have given. So this is an upselling, like from a cheaper headphone to a more sophisticated headphone, from a smaller computer to a larger computer. So this, like this. Now yeah, this is a like 2 important concepts, or you know, algorithms you can say, or approaches normally are used. One is called the collaborative filtering, another one is the content based filtering. Collaborative filtering is just the example we have seen, that if 2 persons are similar, then you can recommend one product that one person has used but the other person did not use. Okay, this is collaborative filter. Another is what we call the content based filtering, or which is the product attribute based. So if I know that this is a person who reads detective novels of certain genre, then I can always recommend another detective novel to him or her based on his previous product attributes. If I know that someone has earlier purchased a pair of sneaker shoe, I can always recommend him another sneaker shoe after 2 years or after 1 year. So these are the two types of filtering approaches are used very commonly. I'm skipping that algorithm. Now let us come to a case study. Please let me know if I'm okay. Sure. This is a use case of demand forecasting. Now we have given I'm giving you an example of retail grocery chain, but it is useful everywhere. If you are running a assembly shop or you are running a production shop, there is you have the same problem. Quickly, I'll go to the this is how a modeling framework has been designed, that there are three because the problem is large. You have 10,000, 20,000 products in a store, you have 200 stores, you have to forecast 10,000 into 200 or 20,000 into 200 forecast every week, say, which is, if you try to do a brute force, you will get it many of these wrong, and different products and store has different natures. So what we did is that we split the problem into 3 stages. In the first, we created certain clusters, that okay, these products and these stores are similar, maybe they are very high moving, fast moving products, low price products, then there could be slow moving, high price products, and this way you can cluster them, and you can either use heuristic based methods, or to improve that you can also use clustering algorithms like k-means or KNN, etc., just to divide the whole universe of products and stores into small groups. Then you build a drivers modeling, because we all know that certain features are always known to us. Certain products will be sold at summer, certain products will be sold during during winters, and many other such things we all know. There are times, festivals and events when sale of certain products will go up. So this is, through this I can always build a first level model. Now you have the error, you can now optimize the error, because the errors will now have the hidden patterns which was not explained through my features model. We have the hidden patterns which can be optimized using the time series models, and then adding the time series prediction and the features prediction, you get the final prediction. Now this is at a very quickly I have taken you through. I have shared this, and maybe professor can share with all of you, where we have detailed the case study, but I am skipping this. So this is how the results were coming for different products, actual versus prediction. And this is an interesting thing, and I will quickly talk and stop my discussion, is that, see, this problem is known. Everyone was doing demand forecasting in some way or the other. Even if you do not have any statistical or machine learning method, you still have to do it, and probably you do it by just taking the last 1 year average or last 3 months average versus the previous 3 months average. Some heuristic method you can apply and get the prediction, but that prediction will have some error. This orange line is these are my products and this is the error. Some of the errors are very high, 50%, 40% and sometimes 90%. But after we implemented this 3-stage modeling, clustering, features modeling and time series, my errors, look at this blue line, my errors have been hovering below 5%. So that is the benefit that a statistical or a machine learning process will bring to a regular heuristic based business. That is the takeaway of this project. This is another, my last slide is that forecast value added. So what it measures is that not necessarily that for all the products my prediction was better than the previous, because some products are very standard. If you just go by the average or some heuristic, you still will achieve an accuracy. So for those 29% of products, my gain from the statistical process was not much, only between 0 to 5%. Some other products, my forecast were better 5 to 10%. That is also you can live with, because the cost of the statistical machine learning process probably is higher than this 5% gain. But for the rest of these 13 plus 8 plus 23%, my gain is more than 10%, which pays off much more than the cost I am incurring because of building the statistical and machine learning based system and improving my demand forecasting. So this is how we measure the benefit of the solution, because the business is always doing it. It's nothing new we are doing. We are just bringing in a more scientific process, and through which are we really able to add value to the business. This is how we have measured it. So this is pretty much I wanted to talk. Paucity of time, so I wanted, otherwise there are some more slides in this case study to go in detail, but I have shared this with the professor and he can share with you, and I am always available if you have questions. But thank you very much for your patience, audience.
So we have time for maybe one question. So can you bring the mic?
Case of fintech, technology in finance, and I take this subject at Manipal. So what models you suggest in demand supply, specifically in healthcare models for say early detection of any kind of disease which can be more optimized?
I am not an expert on this honestly, and I have never worked in healthcare. Very little I work. So one of the healthcare models where we have predicted that for a particular drug, what would be the market size down the line, 3-5 years down the line, was certain early detectors of the fact, because many of the disease we find that there is a history to that.
Right.
Because of the history. So if you just estimate the historical factors that will induce that disease later, that can be one way of predicting. One of the case studies we have done is where we have seen that people who are suffering from gallbladder stone, they have a tendency of growing pancreas related problems and kidney related problems 1 year, 2 year down the line. So today, if you can estimate the number of gallbladder operations happening in a city, that probably will tell you after two years how many pancreas related patients will be there.
Right.
So this is one of the approach, but again I am not an expert
can we
on
like
this.
Make it reusable? Say if we have any code written, I am talking about coding. If you write any code in terms of the healthcare, it can be.
No, I have not, but I am sure you can search and maybe in Kaggle or somewhere you can get it.
Right. Thank you, sir.
So thank you, Mr. Bhattacharya, for giving such a wonderful talk. So I would request Professor Jedamani to present with a small token of gratitude from our department to Mr. Bhattacharya. So, কোথাও একটা গিয়ে দেখুন যাতে ফটোটা নেওয়া হয়।
hello, 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 ঠিক আছে
Hello, hello.
hello, hello, check, check, hello, 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 বেশি করছে
লাইটটা বন্ধ কর শোনো না কোনো একটা জিনিসে হতে দাও আমি এদিকে দেখবো তুমি ওখানে অন করবে আমিও বুঝবো না একটা ফিনিশ হতে দাও তারপরে আরেকটাকে দেখবো দাঁড়াও দেবপ্রিয় আগে এটা শোনো এখানে তোমার এইবার অডিও গেইনটা কমালাম হ্যালো 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 দাঁড়া দেবপ্রিয় পাবে না দাঁড়া ওইখানে ওটা আমি তো এই সারাউন্ডিংটা এটা চেপে রেখেছি না কেন এইখানে আরে বাবা তুমি খুলেছো এখান থেকে কিন্তু এই অ্যাম্পলিফায়ারে না আসলে তুমি শুনবে কোথা থেকে দেওয়া আছে এর যে এই যে এখানে যে ইনপুট দিয়েছি না কালকে আচ্ছা এর একটা ডাইরেক্ট ইনপুট দিয়েছি ধরো অক্সিলারি দাও দাঁড়াও
হ্যালো 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 হ্যাঁ আসবে হ্যালো 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 খুলেছো কি হ্যালো 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 auxiliary to হ্যালো 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 তোমার এখানে দেখো হ্যালো ঠিক আছে হ্যালো হ্যালো ক্লিয়ার আছে কি ওটা বলো হ্যাঁ বাস দাঁড়াও এবার একটু বাড়াই হ্যালো 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 हेलो 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 चेक 1 2 3 चेक 1 2 3 यहाँ देखो नहीं ये तो इसके नीचे आने से फीडबैक मिलेगा थोड़ा अभी देखो हेलो चेक 1 2 3 4 ठीक है हैंडल का तो वो डायरेक्ट दिया हुआ है उसमें अभी तक चेंज नहीं किया अभी इसका देखो खाली हेलो 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 क्लीन 1 2 3 हेलो क्लीन ठीक ऐसे on
It's okay. Hear me now. Okay. It's okay. It's okay. No problem.
Hello, hello, hello. Hello, hello, hello. So our next speaker is our very own Professor Pradeep Kumar Rai. He is the Emeritus Professor of the Department of Industrial and Systems Engineering, and presently he is the advisor of Vinod Gupta School of Management of IIT Kharagpur. He has an industrial experience of 8 years and teaching experience of more than 34 years. He has held many important positions such as Dean of Vinod Gupta School of Management, and he has been enlisted as the member of Board of Governors and Senate for various universities and institutes. He has received many prestigious awards such as the Shinkwa Award by International Ergonomics Association in 2023, SRECSA Lifetime Achievement Award 2024 by Society for Reliability and Safety, APO National Award for Productivity Technical Expert 2022, and PC Mahalanobis Award for Outstanding Researchers by ORSI in December 2018. He is the fellow of World Academy of Productivity Science and the Institution of Engineers, India. So I would hand it over to Professor Rai. Thank you.
It's okay. Can you hear me now? Okay. So, how long I can speak?
30 minutes.
30 minutes, half an hour. Okay. So my time starts at this point. Very okay. So very good morning. It's morning, no? Yes. Okay. So very good morning to all of you, and it's my pleasure, it's my honor to give such a lecture, and I'm doubtful. I may be doubtful because I don't know whether my interaction session will be effective interaction session, and if suppose it is not effective, then definitely I am to be blamed. So I hope that I will be able to conduct this interaction session as far as possible to my ability most effectively. Now the time is half an hour, and my topic of discussion is ergonomic design of human product interface in healthcare systems. I presume you have heard this term interface, and you have also heard this term called ergonomic design. Okay, we are engineers, and as an engineer we must be able to design a product or a process or a system. Okay, the way we have this engineer has been defined in Webster dictionary. We all know, in fact. Okay, principally we are designers. Now, when we are, we are becoming engineers, we say our main focus is on inanimate object. Is it okay? This has been the case all through, in fact. Now, what actually our concern is, any product, any process, any system you create, it is made for the human use. Now, the necessary condition is I must know the engineering design, but the sufficient condition is whether the design is ergonomic or not. If it is not ergonomic, whatever may be the technology you talk about, like we talk about the artificial intelligence, we talk about automation, we talk about the machine learning. So I don't know whether these are referred to as a technology. I don't know. Do you say that this is the technology? Okay, how the technology has been defined, right? Now, if this interface design is not considered, today or tomorrow, all these the tools and techniques will be rejected by the humans. Getting my point? And this has happened in the past. This is happening today. So always they say that if you want to make your system sustainable, if you want to make your system for the human use, is it okay? Whatever the design you produce, and never you forget that we are creating an artificial system. It's not a natural system. Like the farmer, when he creating a system, okay, in front of him or her, the entire natural process is there. Getting my point? So whatever the activities they do, okay, it must match with the natural systems. Whereas we are working with the factory system, and our basic focus is how to improve our production. And if you go through the history of the factory systems, what you will find, it started with slavery. Okay, when so don't treat whatever you do, okay, don't care for the humans. I create a very bad system. Okay, definitely I can get someone from the society, okay, and you can employ them. So this is referred to as the fit man to job. Is it okay? Whether the job you design is of the worst type, You don't bother. 100 such instances. Okay. So definitely someone you can pick up from the societal systems. Is it okay? And he will be put to work. This has been the case. This has not been the case for the agricultural system. Getting my point? So today, what we try to do, whatever you do, whether it is fitting to human, fit to the human's requirements or not, so that you make your system human, HUMANE. That's the goal. And if you create your system a human one, in all likelihood, it will survive for 70 years, 100 years, 200 years. Okay. That means we talk about sustainable manufacturing system, sustainable production system. Okay. This is one approach with which you can create your system sustainable. Is it okay? That means today you are living this life or the health or the fitness. So, there are hundreds of instances where the interface design is the key. Three particular cases, or say like interface design. Where is that? Oh, it's okay. Sorry. So, this will be my topic, and it's a very complex topic. It's not that easy. This is also one of the reasons that it's a very, very complex topic. Anything you are dealing with the humans, okay, that means absolutely at the individual level. Don't say that he belongs to a labor group or I belong to a management group. So whenever we talk about this interface at the individual level, you have to check whether your system is perfect or not. Okay. Now, there's some extreme cases I should refer to. One is underground mining. Okay. Can it be, automated system? Cannot be. And I hope that you have visited underground mines. Extreme working conditions. And it must be labor intensive. There must be a proper match with the technology you use. But unless there is, the human involvement, okay, you cannot carry this exercise. Fine. Second example, where the interface design is a must, like say the cockpit, okay, aircraft. Aircraft design is perfect, but the cockpit design, the interface design of the cockpit, you don't bother about. What might happen? You can guess. Is it okay? Third one, like the operation theater. Is it okay? Doctor is excellent. That operation theater, the way you have designed, is fantastic. Okay, but if the interface design is poor, you know what might happen in fact. Okay, there will be human errors, unintentional human errors. Is it okay? Intentional human error, we don't bother about. You're getting my point. Now, there are many other cases, like say the Bhopal. With the name Bhopal comes to your mind, isn't it? What happened in 1984, 2nd, 3rd December. Is it okay? Now, how do you explain this phenomenon? Why this accident took place? We will not blame the person. We will say the interface design was poor. Is it okay? So, the necessary condition is interface design. Like here, this one is excellent. This one is excellent. Okay, I am interacting, so I may be also excellent. But when you put it on my mouth, its function may be very, very poor. So, 100 such examples. Your, the foot is absolutely all right. The shoe is also very nice. Hundreds of varieties of shoes you come across these days. Okay, when someone is walking, these days you will find. And what I notice that just one variety. Now, how is your feeling interface? Many times what happens, you never, forget that any company you produce, there is a business motive. Business motive. And business motive everybody knows, even the child knows. What is a business motive? Okay. Why are you earning? Okay. 50% of the people doing business, they may be honest, and 50% of the people who are doing business, they are dishonest. And this has been the case since time immemorial. Is it okay? So you must not forget that. So obviously, when you talk about this interface design at the individual level, there is a chance that the company which you belong to, you may be stiffly opposed. There are hundreds such cases, in fact. Are you getting my point? Fine. So what do we try to do basically interface design in today's context? Fit job to man. Getting my point? It's not a the easy exercise. It's a very tough exercise. That means suppose you have employed some 100 fellows. They're working under you. Okay, when I say it's man, how do you define the man? So it is defined with respect to someone's anthropometry. Is it okay? And when you anthropometry you define, it's very clearly defined, okay, scientifically, okay, functional anthropometry, then the static anthropometry, as well as the Newtonian anthropometry. So 100 such designs they're doing. Is it okay? And what you find that this, when you go to the European companies, the kinds of systems they design, is it okay? This design is basically made for the humans. Fine. Unfortunately, in many cases, because we have borrowed the technology, our purpose is different, and in many cases, we don't bother about the interface. He is, he feels that this is a very good design. Why do you shout? That sort of, it's also must be made very, very good for you. Are you getting my point? So this is the issue, and this is a very, the difficult. Today, gone are those days. It's not the era of pure technology. Mind it. It's not the era of pure technology. Is it okay? Even if you change the technology, right, you cannot expect that your production will jump or say increase by 4 times, 5 times, 10 times and all. Is it okay? So if the interface design is poor, and it will be rejected by the humans. There are so many cases, in fact. How many new technologies are introduced? How many new technologies are adopted? Or the, the technology diffusion, which is referred to as the technology diffusion. And today what has happened, that under no circumstances, you cannot compromise with your health, you cannot compromise with your fitness. Fine. So if you be bothering about the interface design, what actually the gain you will have, that means your, the workforce will have acceptable health status, okay, and they will have the right kind of fitness. You know the difference between health and fitness. Fitness with respect to a particular job, right? You cannot be fit for all types of jobs. Whereas the primary condition is, I must maintain my health. Otherwise, your, the license will be taken away. There are many such cases. It is happening today. Is it okay? So, now healthcare systems, interface design in healthcare. You visit any hospital. Is it okay? Don't visit any hospital. Okay. Don't visit to any hospital. Don't visit to any court. Don't visit any police station. Is it okay? So long these 3 places you are not supposed to, or you are not visiting, you are a happy person. Getting my point? Throughout the world, in any culture, right? So, but still, hospital you have to go. Is it okay? You are born and you have to leave this earth. Is it okay? Either today or tomorrow. And at any point in time, I become sick. Now, so you are entering a hospital system as a sick person. And what is expected? That you must be treated by the healthy doctors, healthy nursing personnel. But because of many reasons, what is happening in fact, okay, many reasons in fact, scientifically you can prove, is it okay, that these nursing personnel, including the doctors, in course of time, they are becoming sick. So you know what is the risk involved. If a sick person is treated by a sick person, is it okay? What might happen? There will be human error. And this human error on the part of the doctors will be very, very costly. Getting my point? Suddenly you will leave this world, you will go to the blue. Is it okay? As simple as that. It's a 0-1 sort of thing. Is it okay? Fine. So there are lots of studies, okay, great researchers they have conducted, that how to have the best possible interface design in healthcare systems, so that ultimately the doctors and the nursing personnel they remain healthy, and in a healthy mind, like we say that IIT Kharagpur, so we always say that it is a healthy mind in a healthy campus. Is it okay? And this healthy mind, depends on what kind of interfaces you have. Is it okay? So we carried out this study, in fact, and in a hospital system there are lots of the products you use. These products are properly classified. So what do you try to do first? Before you talk about improvement, you must have the ability to assess the system, evaluate the system. Is it okay? And once you evaluate, you will try to know that what are the deficiencies in the systems, and then you have to mobilize your resources, and you must find out ways and means to remove those deficiencies. And if you can remove those deficiencies, obviously what you expect, that you improve your performance. Is it okay? Performance, quote unquote, is a total concept. Means whenever I say that the system is performing well, that means it is performing for everyone. Is it okay? Not from the managing director's point of view. Is it okay? It also must be, you must be able to explain from the worker's point of view. Is it okay? At all levels. So that's the responsibility. So to propose a methodology to develop and apply such an automated systems. Now these days we talk about automation. A chemical plant is an automated system. Is a hard automation. Is it okay? So I presume that you know what is the types of how it is classified. How it is classified? Hard automation or fixed automation. The next other extremes. Then flexible automation. Is it okay? And FMS is what? FMS is a 100% automated system, not for all types of organization. It's a made volume, made variety. Is it okay? That has been defined, in fact, 100% automated system. So what we try to do, that means only for the dangerous operations. You can identify the dangerous operations or the operations involving, huge material handling. Is it okay? Or like say shipbuilding operations. So there the automation should be focused. It's not for anything and everything you go for automation. Okay. Like there was a study, in fact. Okay. Like one caterpillar is equivalent to 200 persons private life. It's private economy. Now the choice is yours. Now there are hundreds of instances where you will find that if it becomes the labor intensive, the so-called labor intensive, is it okay? The system is perfect, fine, absolutely perfect. Is it okay? Like this teaching learning process. Okay. Can it be automated one? Automated maybe is supported systems. Can you cite one example where you can prove with the data that automated system is the best only when it is a dangerous operation? And dangerous operations in the factories laws, okay, is very clearly stated, in fact, already. You go through the factory laws. What are the jobs which are treated as dangerous operations? What the Japan is doing, they say we will not go for 100% automation. They are not talking about artificial is a 30-year-old technology. It's not the first time. Or the machine learning. So can you name one single Japanese company which is referring to this? If they say that yes, I will adopt artificial intelligence or I will adopt the machine learning, they will tell you this is the job, this is the condition, and it is and one particular alternative. We didn't have any other alternative. Getting my point? So there are many instances where you will find that it's not the first choice, but the last resort. Are getting my point? And particularly a country like ours, is it okay? So we must check whether the technology is appropriate or not. Now, when you say the technology is appropriate, that is, it is applicable in a particular social context, is it okay? Appropriate technology, we used to hear this term. Today, no one is using, as if the technology is imposed on you. Okay. So, what you try to do, that means if you want to make your technology appropriate, obviously you need to consider the interface design. Is it okay? So, that means we must not act as a penny wise, pound foolish. Okay, there are many quarters, they say the quick buck. You want quick buck, forget about all this one. We must not fall in their trap. We must not be called engineer in that case. Getting my point? So, as simple as that. So, human system interface is applied to any of the interactions that occur between humans and the equipment. It has to be there. Humans must be there, right? Anywhere. Can you name a system which is absolutely human free? Can you name a system? You cannot. Fine. So, healthcare providers who use medical devices, and you will find, you visit any hospital system, hundreds of medical devices they use. Is it okay? And for the treating a patient at a particular stage, like say, for a cancer patient, extreme cases, is it okay? Today the medical science has improved. Is it okay? You will find against any disease, the stages are also explained scientifically. How many stages we have? Similarly, for suppose the ailment with kidney, there are stages. This has not been the case even 50 years back, 60 years case. So that perfection is there. So now, depending on in which stage you are, okay. So obviously, great scientists, researchers, they have developed many kinds of devices. Is it okay? So the status is known, and the preventive or corrective measures you can take. Are you getting my point? So we have to check whether these devices are, their interface is perfect or not. That interface is very, very complex one. The machine is perfect. The person is very, very good. When you put the person on the machine in today's context, the young generation, they are asked to, they design this interface. It's a very, very complex one, because in many cases you will find the theories are missing. Is it okay? So if the theories are missing, then what do? You go for empirical study. So your knowledge, you can increase your knowledge base in this particular area if you go through several case studies. Is it okay? As such, the theory in many cases is missing. We can have certain, hypothesis and all. That's it. Is it okay? There may not be any law. There may not be any theory. So that's why, what you need to do, that means you select one medical device and then you check that for what kind of disease it is being used, who are the patients, is it okay, who are the doctors, the exposure time and all, and you constantly record, you collect the data, relevant data, and after you analyze, you say whether this medical device is a good design or not based on the interface. That's it. And it may so happen that the medical device in a particular health condition of the nursing personnel may be found to be very, very good. But in another situation, in another, the conditions, it may not be found as a very good device. Is it okay? So 100 such cases, if some one hospital in one particular country, this is running perfectly all right, and you say, "Ore, why don't you use it? It is your fault." So that sort of, okay, ideas will not help you. You must not be biased with any particular, the opinion. You have your own, the workforce, and with respect to that workforce, you say whether the interface design is perfect or not. Okay. So, these are the, always there must be classification. So, class 1 devices, low risk devices, already they define it like this. Class 2 devices, intermediate risk devices, there are many devices, I have named them in fact, and class 3 devices, high risk devices, you cannot avoid. Is it okay? So, how to take preventive measures? So, understanding the characteristics of principles of work system design provides the foundation for healthcare organization to engage in work improvements. This is a general statement we have made. Physical characteristics you need to consider, for instance, height, weight, physical strength and reach envelope. Basically, it is a part of anthropometry. Is it okay? So, it starts with the anthropometry. Is it okay? So, what is anthropos? It's a Greek word, no? Anthropos. So, measurement of humans. How many, human characteristics you have till date? Human characteristics, anthropometry, any idea? 50, 60 till date. How many bones we have, 206, isn't it? Okay. How many human characteristics? Okay. Till date, right? The researchers have identified how many? 3,300. Till date, it is around 312, and they are all properly classified. Is it okay? So, to what extent a particular device may affect one or more of these human characteristics? Is it okay? Over time period. At instant of time, okay, immediately it may be affected or over a period of time. Is it okay? So, a lot of studies are going on, and this is a part of the interface design. Is it okay? So, unless the interface design is accepted, you will not accept, is it okay, any technology, any product. That is your commitment as a designer. No compromise on the human health, whoever he is. Getting my point? This has not been the case, in fact, for many, many years, even 60 years, even today you will find in unorganized sector, like hundreds of, the construction workplaces you come across these days. Is it okay? And do you have any feeling for those workers? If he is my son or daughter, then I would have shouted. That's the human quality, no? But today what has happened, that you must check what are the preventive measures. Some of the jobs you cannot avoid. Is it okay? Like many kinds of height jobs. Is it okay? 40-story building is working. Someone you will find on the rooftop. Is it okay? Someone is working. The crane operator. Is it okay? Have you thought of that what kind of problems he is facing? Is it okay? Even in the steel plant, the crane operator. Is it okay? The crane drivers, whether he is getting right kind of interface or not. As but today the awareness has come. Getting my point? Like young generation, they are concerned about this. Our generation were least bothered about this. I am telling you, you become engineers, you don't bother about all this one. These attitudes, in fact, today you cannot do. Getting my point? You cannot escape. You'll be caught red-handed. Okay. So now scientifically you must know that what is interface design, and so all these details are here. The time is very short. So various dimensions to be used characterize the task, difficulty or the challenge, content, variety, repetitiveness. Okay, it's a very tough exercise. I've told you. Is it okay? So that's why, that is also one of the reasons many companies they try to avoid. As simple as that, in fact. Okay, but if there is a pressure from their principals, so located in European company, they will say immediately. Are you getting my point? Whereas there are many organizations, like if you go to the non-engineering sector in our country, you will find, is it okay, that over the years They've created a system, 100 such cases are there. Is it okay? You will find they have already created a human system, 100 such examples. Is it okay? All these are here, the time is up.
I mean, technically yes.
Technically yes. So I have to conclude.
So you can conclude
So
in 2 minutes.
no, it's okay. We'll in 5 minutes I will complete. Okay. Because the others are waiting, no? Can't do that. And as I've told you, this is a very, it's a very complex exercise. Okay. Very, very complex. We know as a mechanical engineer what is a mechanical design. Okay. We know it very well. But compared to, that sort of exercise, if you are engaged in this exercise, you will find that your individual knowledge base is very, very poor, and that's why a group is formed, a team, and they will be working on that. Getting my point? Because there are many dimensions. There are many dimensions, not only just engineering dimensions. Like today we never say the design with respect to mechanical engineering or in mechanical engineering. We say mechanical systems engineering. Getting my point? That means integrated approach. Like for the automation, automated systems, okay. So before we go for automation, there must be integration. So integration is a very tough job. It's not that easy. Getting my point? So here also, when you go for this interface design, is it okay? Many of the, the dimensions you have to integrate together. Is it okay? And then you have to test. So this is a sufficient condition to be fulfilled. So these are all general simulation. Many kinds of software you can use. Is it okay? They developed. And evidence-based design, then the task analysis, all these details are here. Okay. So you just go through workflow analysis. Okay, you must not miss a single point. Is it okay? So task analysis is a must. Okay. And then these are the workflow. There are many kinds of tools you have. Is it okay? So you have to classify is which tool you need to use for which purpose, whether this particular tool is relevant for this kind of interface design. All these details you must know. Getting my point? You must not be biased with a particular, the opinion and all. Getting my point, right? So, so work system analysis, the biased thinking will not help you. Is it okay? Alternate thinking, and no design is foolproof. So always there is a scope for improvement. So can you, can you suggest, some companies, the contribution, okay, contribution specific with respect to the interface design. As soon as you say, you remember this word or you uttered this word interface design, which company comes to your mind? Benchmark organization. The company is, it's not a company, it's an organization, NASA. Are getting my point? That is the benchmark organization. So if the, the astronauts, is it okay? Can you think of what kind of interface the Neil Armstrong used to have? Right, okay, fine. So that's your ultimate interface design. They will not, whenever the humans are there, you need to consider interface design. That's it. Okay. So work system analysis is this one particular model we have. Patient safety, all these details are here. Healthcare systems is a very complex one. Is it okay? And it's a labor intensive. Absolutely labor intensive. That's it. Okay. Supporting performance, automated system. A few examples we have taken up, in fact. Interface design help for professionals. This is just one example. This is MRI. Okay, used in fact. Okay, constant exposure. What happens to the nursing personnel? Okay, so how to protect someone's health? Is it okay? Come whatever may. So this is all. So focus is design. So whenever someone says that I am opting for ergonomic design or human factors engineering, My focus is design. That's it. Design is the first, maxim, and the second maxim is existing system design and analysis. Is it okay? There is a second maxim. You must remember, in fact, sometimes it is referred to as the human factors engineering. That means I am putting the person on the job. I must ensure that not only his body, but also his mind is on the job. So what is the advantage? Advantage is, in all likelihood, he will be intrinsically motivated, like the farmers are intrinsically motivated, like the weavers. Okay, whether you go to Kanjivaram or say the Varanasi, you will find the weavers are 100% self-motivated. Nobody is directing to them. Whereas in the industrial systems, is it okay? Hardly 90% of us, okay, as a worker, as a supervisor, as a manager, as a managing director, they may not be intrinsically motivated. So that's the challenge. So if you consider interface design, okay, in all likelihood, majority of the people will become intrinsically motivated. So you don't need to control them. Are you getting my point? Are you controlling your mother's activities? Okay. So can you create that sort of mind state? So there are hundreds of instances, and so that the company will be ultimately benefited. Is it okay? In Indian culture permits this one. That's why we accept all sorts of opinions and all. Is it okay? The integration and constantly you have to update your thinking. Don't be biased to a particular thinking, and then only the interface design is possible. And you must not believe in any other viewpoints excepting the scientific viewpoints. That's it. Database. Thank you so much. Okay, I guess that I could this interface design. This is the interface. Okay, I don't know effectiveness of this interface, right? But I hope that someone will become interested and they can relate this particular issue with their, the problems they find at their workplaces. Thank you so much. Okay.
Thank you, Dr. Roy, for this wonderful keynote address. So we may have time for one question. So anyone wants to ask any question? Professor Rai?
What can be one suitable threshold?
Yeah, can you?
Suitable thresholding technique. Say, if you are working on a problem of early detection of osteoarthritis in orthopedics, from AI perspective.
What is that? Okay, can you?
Sometimes what happens when you are trying to categorize diseases into mild, moderate, severe, say AI, feature abstraction and classification.
With respect to?
With respect to AI.
AI.
No, I'm just telling what we had done on osteoarthritis. Now, if we come to sometimes what problem we face is when there are artifacts, right? Artifacts means we are not able to clearly say whether it is mild or that there is not a problem. So osteoarthritis, it is not osteoarthritis, right? It could be some artifacts or early stage. So do we have certain thresholding techniques in ergonomics which can be brought in?
Yeah, definitely, because ergonomics is the techniques which you say even at the individual level, it is applicable. Is it okay? Designed for everyone. Getting my point? That's the goal. Designed for a group. Certain times, no. Suppose you are designing a a locomotive engine. Okay, diesel engine. So it is to be made the design for a group. But is the pen. You are using pen. Just one example. How many varieties you have? In our time, there is hardly one or two varieties. So that design is imposed on you. Your handwriting quality is to be affected. Today, hundreds of designs are available. Is it okay? So many such products these days, even for the shoes we have, there is a standard sizes in fact, if it is possible. If you can standardize them, you can group them, like the shoe is an example. Okay, like your, the clothes. is an example. But for the pen, you know, hundreds of varieties, just you pick up one and you feel this I will continue. Is it clear? Similarly, this one is the specs, is a perfect application of interface design. Is it okay? So, our goal is designed for everyone. Now, it may not be possible for a particular machine tool, CNC machine tool, but still at the interface or even at the computer, is it okay? The laptop, the interface design is horrible. So, young generation is suffering, in fact. Okay, so it is designed for everyone. That's your goal.
So thank you, Professor Rai. So I would request Professor Anand to come and felicitate Professor Rai with a small token of gratitude from the conference organizers. So next I would request Professor B.G. Menon to come and introduce our next keynote speaker, Professor Bishwajit Mohanty.
So good afternoon to you all. So this session on keynote speech will be delivered by Professor Biswajit Mohanty, Professor, Department of Industrial and Systems Engineering, IIT Kharagpur. And before we start the keynote, I would like to give a brief introduction about Professor B. Mohanty. So Professor Biswajit Mohanty is a professor at the Department of Industrial and Systems Engineering at IIT Kharagpur. He was Dean Planning and Coordination of IIT Kharagpur during 2013-2017 period. Earlier, he was the head of the Department of Industrial and Systems Engineering during the period 2009-2012. Professor Mohanty has obtained his BTech Honours degree in Mechanical Engineering and his MTech and PhD degrees in Industrial Engineering and Management, all from IIT Kharagpur. He has a rich and varied professional career with over 6 years of industrial experience and more than 33 years of teaching, research and industrial consultancy work experience. He has guided 22 doctoral and about 200 undergraduate and postgraduate level dissertations. He has carried out more than 20 industrial consulting projects and 10 sponsored research projects. He has got about 100 publications in a number of well-known international journals. He is also an author of the book Responsive Supply Chain, published by the prestigious CRC Press of Taylor and Francis. He was also a visiting faculty to the Asian Institute of Technology, Bangkok, in 2000s. So I extend a hearty welcome to Professor Biswajit Mohanty to this keynote session. And today's topic of this keynote is System Dynamics Modeling, Archetypes to Strategy Development. Sir, the dice is all yours, please.
Right. Okay, so first of all, thanks Professor Menon for this very nice introduction. So please put that slide. Yes, right. No, this is to be closed. It is to be closed, and the next one is to be put. Right. So first of all, this is the topic: system dynamics modeling, archetypes
to strategy development. So many words, I don't know how many, what, what you can make out of this. But probably as I go on and at the end of my talk, probably it would carry some meaning. So let me first start with some basic concepts of system dynamics. What is system dynamics? System dynamics is a methodology of social systems analysis and design at the aggregate level using continuous simulation. Alright. It was developed in late 50s by J.W. Forrester at Sloan School of Management, and you can read all these things what it does. I will not go into them. I will only tell that after Forrester has talked about system dynamics, that time he used to call it industrial dynamics, is all right, in 1950s. After that, all IIMs in this country and many IITs including IIT Kharagpur included it in its syllabus, and system dynamics was being taught for maybe last 50 years or so. But then after it was named system dynamics, people realized that its maximum application is in the business world and particularly to the topic of sustainability. Is it all right? So, it is now named also as another name, it is not that this name is gone, business dynamics. And if you are interested, one of the best book on this topic is Business Dynamics by John D. Starman. Is it all right? He is a MIT professor, and if you look at this book, it is an excellent book. I mean, it has got all the relevant what you call examples and things that you can think of. Is it all right? I will tell a little bit more maybe later, but let us quickly come to the topic. See, explaining the system's behavior in terms of its structure and policies, that is the basic idea. Suggesting changes to the structure, policies or both, which will lead to an improvement of the behavior. And see, look at these two axioms. System structure is made up of feedback loops. System behavior is a function of system structure and policies. When I say use the word system, I mean not just any system, it means all systems, right. It could be a business systems, it could be a forest systems, it could be an environmental system. All kinds of systems are ultimately guided by the structure, and the structure is made up of feedback loops. So, if you can create the right kind of feedback loops, you can control the behavior of the system. And you can understand how big a tool is this, because almost in every system that we see a behavior pattern. The question is, do we like this behavior pattern? We may not. Today, everybody is talking about AI and machine learning, but then all of these are about big data, not small data, not a little bit of data, lot of data. Okay, fine, you have lot of data, and with that lot of data, you have identified the current behavior. But what is the guarantee that behavior will continue in the same manner? It may not. The today's behavior may not be tomorrow's behavior. The behavior pattern may be a little bit different. How do you say that what is the likely behavior tomorrow? It does not depend on the data alone. It depends on the system structure, and the structure depends on feedback loops. Is it all right? This is what exactly we are trying to tell here. All right. So, quickly let us see what is a feedback loop. So, look at, this is the first example, a positive feedback loop. A positive, sorry, just a minute, I got too far, right. So, this is a positive feedback loop, right. Positive feedback loop, the positive word of mouth, most sales, most satisfied customers, even better positive word of mouth, and it goes on. Is it all right? It is taken out of context. People don't like to visit Darjeeling anymore. Why? Very crowded, right? All kinds of names you can see if you open Facebook, all kinds of name. I don't even know those names. So, let us say some X, fantastic place, let us go there. You go there, have a very nice beautiful village, fantastic scenery, very good weather, good hospitality, extremely satisfied. Come back, tell your friends, the friends will go there also. And finally, the entire Kharagpur and Midnapur going there. All the houses are occupied, is it not? Something else happens, but that something else is not here. Only the positive part is taken out of context. So, one part of that behavior is shown here, that is the positive thing, positive word of mouth, even better, satisfied, things are going on and on and on. Alright. So, this is one example, but then there could be negative feedback loop also. The negative feedback loop, here is an example, that if you place order, it increases your inventory level, and if you have a desired inventory or stock, that gap, if you perceive that, look here, the inventory level has gone up and we wanted that much inventory only. So, you do not order that much anymore. Control system, is it not? You want a certain kind of inventory, so you try to control, and that control is usually through a balancing loop, which usually called negative feedback loop, sorry, a balancing loop or things of that sort. Now, what happens when there are both negative and positive feedback loop? In fact, this is the typical fixes that fail kind of scenario, where you have a cash problem, so you borrow money, and as you borrow money, your monetary crisis reduces, your cash problem reduces, a negative feedback loop, it is a kind of balance. But after some time, your debt situation becomes worse and monetary crisis increases further, is all right. So, what has happened? You have done a fix, you have borrowed money to get over your monetary crisis, but then it creates a much worse debt situation. That is called the fixes that fail, borrow money to make payments. I think all of us are aware of this. We have some stomachache and we take some over the counter medicine, stomachache is gone, extremely happy. Keep on taking it for 5 years, 10 years, 15 years, other very big health problem comes, and even that stomachache comes back again. Now, that tablet does not work anymore. Alright, then Professor Ray says hospital, do not go there, but you are forced to go there, what can you do? Doctor, save me now, hello, take that medicine, hello sir, already over, not working anymore, fixes has failed. So, here is a combination, and this has been taken from business dynamics book. Like I said, one of the best book currently in the world, business dynamics on this topic. It does not mean that is the only book. There are several other books, including one written by my guide supervisor, Professor P.K.J. Mohapatra, one of the very good book, right. If you have time and interest, you can see that book also, fantastic book that he written. But then from Starman's book, this is the thing, that is the schedule pressure dynamics. Look here, how many loops are there? First of all, when there is a, what is schedule pressure first of all? See, many of you, you may be joining the students out here or professionals, they may be working on IT or IT related jobs, including AI. All of these projects, I mean they companies are consulting companies, and they get individual projects, and the projects have deadlines. Now, usually what happens, initially you do 50% work in 50% time, everything is fantastic, you are happy, everybody is happy. suddenly a quality check is done and a little bit of error has been found. The problem is, in such projects, one error does not mean one rework. One error probably mean 100 rework. Suddenly you realized that you thought 50% time gone, 50% work left. Suddenly you realize that yes, you have 50% time left, but 70% work remaining. What happens now? Schedule pressure, that is called schedule pressure. So, what you can do, one thing you can do is burn midnight oil, work overtime, completion will be faster, work remaining reduces, schedule pressure decreases. But pitfall, after some time by keep on doing overtime, you have fatigue and then your productivity falls, midnight oil burning does not work anymore. Second thing what you can do corner cutting, give less time to each work, do faster, is it not? Try to work very fast. Most of us do it when project deadline comes, is it not? What happens? Time per task reduces, productivity improves, schedule pressure decreases through this loop, all these connections. But then if you reduce time, you make more errors, and as you make more errors, your productivity decreases, schedule pressure increases. So, all these loops are not that they are individually there at one time, or it is like first this happens, then that happens. No, not like that. All are present at all the time. And when we say behavior is a function of structure, all these loops are there together. And I showed here, at least Starman shows 4 loops, there may be more loops also. So, if you identify all the loops of the system, you know that is the system structure. Then you have to understand whether there is a time gap between these loops. That means, which loop is dominant at which point of time. You have to understand them, but then as it may be very complex, it may be too difficult. When it has become too difficult, then you have to put some numbers, go to computers, do simulation. Alright, I will not go into simulation or those things because it is a full subject, right. I have only half an hour. So, I will not do that. I will simply tell that if you are a visionary, you look at this diagram, you can tell how the behavior pattern will be. But if you are not a visionary, then you have to put numbers, go to computer, simulate and see what behavior pattern is coming. Is all right, and that is system dynamics. Excellent software is available. We at industrial engineering, we at one time we developed so many software. 2 of them were Dymosim and iGrasp, and it was very popular in those days. But later on we gave up, because now excellent software is available called Stella, PowerSim, VenSim. So, all these software, any one of them you can use. Stella is also called iThink, and you can do all these simulations, all right. But if you do not understand, garbage in, garbage out, is it not? So, be careful. So, these are some basic system behavior. It could be exponential growth, it could be goal seeking behavior, it could be S-shaped growth with overshoot, it could be oscillations, or it could even be overshoot and collapse. Finally, there could be overshoot and collapse with oscillations. So, these are some basic behavior pattern. You have to understand your behavior pattern of your system could be a combination of them or various combinations of them. Is it all right? If you understand the feedback loop structure, you can also understand the behavior pattern. And if the behavior pattern is not what you like, then try to change the system. Is it possible to change the system? Everything cannot be changed. Certain things can be changed. You have to understand the leverage points. You have to, sometimes a little bit of intervention can bring lot of change. you have to understand those leverage points. If you can do, you can bring big changes with small interventions. Is it all right? And that is what policymakers should do. Is it not? That is the job of the policymakers in all systems. Is it all right? But anyway, let us see to what exactly we are trying to do here, and what is the main topic, how system dynamics modeling can help in strategy formulation from archetypes, right? That is the topic. So, very quickly I go there, probably more than half time I have already consumed. All right. So, I have half the time left, maybe go little further. Let's see how it goes. All right. So, some of the research directions that I found out from recent publications in System Dynamics journal. One of the best journal in System Dynamics is System Dynamics Review. Is it not? There is an International System Dynamics Society, it is their journal, System Dynamics Review. That does not mean that there are no other journals. There are many other journals which are very famous in our parlance. They all nowadays accept system dynamics. And let me tell you, system dynamics has been realized by people, particularly after the advent of machine learning and AI. You know why? The idea is, you see, it is very easy to tell what to do with data. All right, you model the data, you cluster the data, you try to interpret the data. But after interpreting the data, how do you go further, right? Then you go back to the old regression models, is it not, and similar models. But problem of most of these regression models, many a time either you overfit or you underfit data. When you do overfitting, they explain past behavior very nicely, but they fail to predict the future behavior very nicely. That is the problem. So, if you read forecasting literature, you will see there are both time series forecasting and the causal forecasting. So, this falls under that causal forecasting areas, is all right. So, that is where a renewed interest has come in system dynamics, and you can see increasing number of publications in various journals. All right. So, some of the areas: sustainability, transformation and transitions, then the resilience. Resilience is one very big area, including supply chain and many areas. System dynamics fundamentals, dynamic supply chain and transportation modeling, healthcare and food security dynamics, security and AI. So, these are some of the areas where a lot of work is currently being carried out. Is it all right? Some of the major themes, let us see that, all right, probably I removed that slide, anyway it does not matter. So, kind of work that we have done in from 2020 in this broad area. One is on systems archetypes, I will come to that very quickly. Food security dynamics, policies for peak stock management, circular economy, extended producer responsibility of end of life tires, software project dynamics, knowledge growth and team composition, PhD dynamics, analyzing PhD milestones, resilience, emergency sourcing, internet relationship among resilience, robustness and bullwhip effect. So, these are some of the work that we have done, which can be broadly classified into dynamics in the last 3-4 years. Is it all right? Coming to systems archetypes, now let us quickly come to the systems archetypes. These are templates of system structures that one should be aware of. Now, what are these templates? These templates are all basically combination, see I showed that schedule pressure dynamics, 4 loops are there. Now, these are some combinations kind of things that you can observe in various systems, and you should be aware of them. Why? Because most often the end result of these are bad, they are not good. So, if these archetypes are present, they are not very good structures. So, you should be careful of them, try to remove them, try to build policies around them, so that the bad effects can be removed. Alright. So, like fixes that fail, shifting the burden, limits to growth, drifting goals, growth and underinvestment, success to the successful, escalation, tragedy of the commons, right. So, you can read articles. There is a fantastic site www.systemdynamics.org, right. It is the official site of System Dynamics Society. You can also get all the conferences that has been held in maybe last 20-30 years. You can get all their proceedings, is it not? And there are a lot of excellent material available also. Anyhow, so I will discuss only three of them very quickly. Shifting the burden. I talked about fixes that fail. Here, see, fixes that fail simply tells that if you use a fix, it fails. But then that fix not only fails, it creates the fundamental solution weak also. Look here, I had stomach pain, I go to the doctor 10 years later after taking those tablets for so many days. Fundamental solution should have been, I should have changed my food habits, I should have done more exercises, I should have had healthy lifestyle. Now the question is, after 15 years, it may not work anymore that much. You know, something like a mother who is going to be mother, is it not? Some lady who is going to be mother, it is said that let her eat very good food so that the child becomes healthy. In India, we neglect, neglect mothers, but we suddenly become aware of them before childbirth. No, she should eat very good food. But do you know what doctors say? It's not what you eat now, what you have eaten in last 20 years. If she has eaten properly in the last 20 years, obviously she should give birth to a healthy child, is it not? So, it is not just today. What has happened? If you have ignored, and you have gone for symptomatic solutions, the fix, the fundamental solution becomes weak. So, these are three different loops. The side effects will create fundamental solution weak, that is called shifting the burden. Alright. So, you will not read all these. Some examples let us see. Selling more to the existing customers rather than broadening customer base, paying bills by borrowing, taxing more the salaried people rather than widening the tax base. We are a country of 142 crores, only 2 crores people pay income tax. What is going on? Is it all right? Does it mean that India has only 2 crores people who can pay income tax? Definitely not. Is all right. So, what governments are doing? They are forcing people that no, you cannot escape even 1 rupee. No, we found out you got 20 rupees there, pay 6 point something to income tax. All right, very stringent because it is recorded. All right, here is another example. You have low productivity, instead of time up. I'll be fast, almost done also. See, low productivity, instead of process improvement, you increase manpower. So, what will happen? Product quality will suffer. So, as the product quality suffers, process improvement becomes that much more difficult. So, there are several such examples. This is another thing about IT needs. If you outsource IT needs, your IT expertise goes down, and then you cannot do development of IT in-house. You have to depend on the consultants. So, this is what happens in shifting the burden. The second one is drifting goals. This is easy one. So, there is a quality goal, there is a pressure to adjust goal. You know why? Because improving quality is not easy, it takes time, there is a delay involved. So, by the time, okay fine, let it go like that, is all right. Our MTech students are all getting above 9 CGPA. they all must be good. Why 9 only? Let us give them 10 CGPA. Everybody let get 10 on 10. After all, in higher secondary and class 10, they got 100% marks. So why we are giving 9 CGPA? You know, something like that. So that's the thing. But then nobody believes us anymore. Some student is like 9.9 CGPA. Okay, tell me what is work system design, sir? We don't know. What is simulation? No idea. So the question is then, but your CGPA is 10. What is going on? So this is the problem. This is the problem. Isn't it? That's the drifting goals. That's drifting goals. Everybody is easy because developing quality takes time. Meanwhile, let it slide. All right. The third one, I'll quickly go to the third one. That is the growth and underinvestment. See, tremendous growth is taking place. Like, examples, Air Deccan, Damania Airlines, Kingfisher Airlines. Even today I heard even Indigo has fallen into this. When they came first time, they are very good, fantastic. So, more marketing, more demand, everyone goes there, very good facility, it's all right. But then after some time, because everyone goes there, now they need more capacity, and capacity building needs time. In fact, there are two delays in capacity building. One is we have to realize that capacity must be built, and second is after realizing actually getting capacity. See, in airline business, getting pilots are difficult, getting ground time is difficult, and also the maintenance is difficult, buying aircrafts is difficult. All of these take lot of time. What happens? If the capacity is not built, but through marketing demand has gone to a point, your performance becomes so bad that with lot of marketing still your demand does not increase anymore. Sorry. We are almost at the end. This one, that you go there. Okay. So that's the thing. So that is what happens. You see, this is the kind of thing that is we are growing, but there are underdevelopments. Is it all right? So I'll just take just 3-4 minutes more in my last topic, because if I don't say that, then main thing is missing. So far probably you got the idea what I meant by systems archetypes and what I meant by system dynamics modeling. Now the question is, how do I relate all of them? Now here Arup comes to the rescue, my student Arup. I have taken his slides, so don't mind, I will show your slides. All right. So archetypes to strategy development. Now the question is, why are organizations or markets slow to transform towards sustainability despite the abundant well recognized opportunity it provides? Struben and Kapmeier 2023. What this paper says, that there are several reasons for it. Everybody is talking about sustainability. Every paper you see today, it is about building some sort of sustainability into systems, but still it is not happening. It is big talk only, it is very slow. In our country, we understand that we do not put enough money into them, but what about European Union, what about US, Japan? They are putting so much money into it, but in spite of them the transformation is so slow. Why is that? So they identified some reasons like dynamic complexity, increasing pressure for short term results. So what strategies and approaches can help move actors individually and collectively towards sustainability transformations rather than just facilitating incremental changes? So what should be done? That paper has given like 30 or 35 different directions. It is a very good paper. Those who are interested can read this paper, but we want to use it in a slightly different manner. All right. What we see, this particular work that Arup is doing currently, a circular supply chain model for end of life tires under extended producer responsibility. I will tell very quickly. I will show this slide little later. So, this is his slide, first slide. First of all, what is end of life tire? End of life tire is, now look here, yesterday Professor M.K. Tiwari has shown, if you see one of his slides, he has shown that 70% of the transport business in our country is by trucks, is it not? And the trucks use tires, not one, but 6 to 8 to 14, so many tires, is it all right? All these tires have life, and after their life is over, they must be changed. So, two questions comes, what do you do with the end of life tires? What do you do with them? These are the things that you can do. You can do retreading, incineration means burn them, reuse or recycle. The sustainable thing is this one, recycle, not the other ones. Some people also do landfilling, but then if you landfill the old tires, all the resources that has gone into that tires are actually wasted, is it not? Very good resources are wasted. So, the idea is that now there is a thing called EPR, full form of EPR is extended producer responsibility. What does it mean? It means the company who sold the tires, they should take back the tires, and not only that, they must recycle, is all right, they must recycle them and get all the materials out of them. So, there are different kinds of recyclers with certain facilities. So, Arup has found out some very good technologies that can be used for doing it, and then he proposed a system of this type, to really improve, and like a great mathematician, he has done lot of mathematics with some values and shown that it is possible and it is a very good thing. And he published one paper and has been very happy since then. But the ground reality is, it is not happening. Although the government of India has talked about extended producer responsibility, we are very slow at that. So, why are we slow? We identify there could be three situations. One is that little effort among tire producers in taking responsibility of end of life tires, shifting the burden archetype may be working here. In spite of goodwill, vehicle owners are not practicing sustainable disposal practices, drifting goals archetype. Government of India has announced the implementation of EPR, but little efforts are seen in installing recycling facilities, growth and underdevelopment archetype. So, we understand that all these systems archetypes are applicable here, and chances are mainly for Arup to model them and publish more papers. But at least if anyone reads those papers, can at least understand that something should be done. Unfortunately, apart from guide and student, very few, less people reads. Some people read and refer those papers, because they need to write another paper. So, okay, that is all for me. This is my final slide, please read it, and that is the thing I wanted to tell. So, if it makes meaning to you, the title, I think my job is done. All right. So, if you think that title is still meaningless, then I have wasted your time. Thank you very much. Okay, any questions?
So, thank you, Professor Mohanty, for the wonderful talk. So, any questions? We may have time for one.
So, do not ask what will be there in the exam paper on Monday.
Sir, what is meant by the stock and flow failure problem? And
no, it is a very difficult question, and this is a very big issue, very big issue. It needs a lot of discussions. So, we will answer later on. All right, take it offline. He wants to ask, Shatanik.
Sir, Actually, I'm not very expert in this area, but still, I don't know whether it is a very naive to ask or not.
Yeah.
But when we simulate some kind of a situation, like as you have given some examples, so what is the limit of considering number of variables? Like how many things can get affected?
Very good question. Okay, I understood your question. See, the what I would like to say that system dynamics modeling should be limited to only those portions where you have understood the dynamics. Is it all right? So, it does not mean that other analysis is not required. In fact, if you take up any system dynamics modeling, you must spend reasonable or considerable amount of time in everything else that you do, like statistical analysis or any other kind of analysis that you are doing, operations research modeling. Do that, understand them and identify which part of the model you are really interested in the dynamics, and confine your SD model only to that part. All right, and rest of the things you connect through other kind of modeling. Is it all right? All right.
Okay, so thank you, Professor Mohanty. I would request Dr. Abhishek Sharma to come and felicitate Professor Mohanty with a small token of gratitude. So our next speaker is Mr. Samir Abdul Aziz, and he is joining from Russia. So just give you a reminder that we are living in Kharagpur, right? So Kharagpur is a railway town, and association with railway means we are also familiar with delays. So we are about running at a 45-minute delay. So please bear with us, and let us invite Dr. Mr. Samir Abdul Aziz from Russia. He is a scientist from DRDO. So I'm inviting Dr. Anand to introduce Samir Abdul Aziz. Please.
We have our last speaker of the day, who's joining us online, Mr. Samir Abdul Aziz. Mr. Samir Abdul Aziz is currently Counselor, Defense Technology in Embassy of India at Moscow, Russia. He is the Group Director, Technology Management at Naval Physical and Oceanographic Laboratory, NPOL DRDO, located at Kochi in Kerala. He is a mechanical engineer with post-graduation in industrial engineering and management from IIT Kharagpur. He has around 20 years of experience in the areas of design, analysis, simulation, development and testing of sonar systems for the Indian Navy. He received DRDO Award for the Best Technology Managerial Services in 2019, the DRDO Young Scientist Award in 2014, the Director's Gold Medal from IIT Kharagpur in 2009, and the NPOL Awards in 2009, 2012 and 2014. He is also the project director responsible for establishing a state-of-the-art lake test facility for R&D in underwater systems. His research interests include sonar systems, structural dynamics, machine design, ergonomics, industrial engineering and systems engineering. Today, Mr. Samir will be speaking on the topic Sustainable Future Through Digital Technologies, Some Perspectives from Around the World. We are extremely happy to have you, sir. Over to you.
So good afternoon to all of you.
So Samir, just 1 second. We have one more presentation after this. So just to remind you. All right. Yes, over to you, Samir.
Thank you. Thank you for that nice little introduction, and good afternoon to all of you here. It's morning time in Moscow, but I think you are approaching the lunchtime there in Kharagpur. First of all, let me thank the organizers for this invite to this conference. It's always back to be at Kharagpur, although virtually. And the topic that I'll be talking about today is about sustainable future through digital technologies, and some perspectives that I would like to share from different cases around the world. So I'll just share my slide. I'm not sure whether it is audible. Is it audible there? The slide. I mean, is it visible there? The slide. Is the slide visible to all of you there?
Yes, 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 it is
Okay,
visible.
excellent. Yeah. So basically, I'll be sharing some perspectives on how we can, how digital technologies have been shaping our lives. The very fact that I have been just after breakfast here in Kharagpur, sorry, in Russia, is talking to all of you. I mean, approaching lunchtime there in Kharagpur. Geographically displaced by thousands of kilometers, many thousands of kilometers. It is all possible due to digital technologies, and we have been ensuring this. Even through what you call critical times, like COVID and all, where people all over the country were connected through digital technologies. So basically, when we look at the role of engineers, it is reported that we make up roughly 2% of any country's population. However, we exert an outsized impact on the lives of citizens and on society in general. Right from the industrial revolution through the information revolution, engineers through their work have played the roles of sociologist, economist, political scientist, and policy analyst, changing the patterns of our lives. Socially embedded innovations, like for example, mobile phone or internet, are vastly transforming the economic, cultural, and physical fabric of people all over the world. And quite often the debate is over how the technology fits into society, and it is not necessarily over how society is reflected in the technology developed. For example, how the technological system reflects pre-existing bias and inequality. We are passing through a phase in history where innovation, design thinking fever, etc., are at a very high pitch, and where engineers are the kings. And when the products of engineers, that is the technology, is shaping our lives, social relationships, habits, and even our own needs in a kind of uncontrolled technology-centered evolution of our society. But then the overwhelming problems of our day-to-day life have not yet been alleviated by technological systems, as is proved by the subpar quality of life, of quality of a lot of people. Billions of people on the planet. So sometimes it is also the fact that technological systems, they themselves have been the cause of such problems. It is always important to have some goals to strive for, especially when we think of achieving a sustainable future. So right in 2015, the United Nations had adopted an agenda for sustainable development by 2030. And this provides a shared blueprint for peace and prosperity for the people and the planet, now and into the future. So at its heart are 17 sustainable development goals. We call them SDGs. And these are an urgent call for action by all the countries, whether they're developed or developing, and it's a part of a global partnership. So all these countries recognize that ending poverty and other deprivations must go hand in hand with strategies that can improve health and education, reduce inequality, and spur economic growth, all while ensuring that issues like climate change are tackled, and while preserving our own resources like our oceans and forests, etc. So the overall aim is to build a better future for all of people, including those millions who have been denied the chance to lead a decent, dignified life and to achieve a full human potential. So there's an inherent feeling that we can probably be the first generation to succeed in ending poverty, but just as that, we may also be the last to have a chance of saving the planet. So the world will be a better place to live by 2030 if we succeed in these objectives. The future of humanity and our planet, to a large extent, lies in the hands of engineers. So by mapping the road to sustainable development, engineers can ensure that the journey to a better world is successful and reversible. So let's look at how digital technologies have been instrumental in continuing to take on this global issue of sustainable development. So all of you would connect with INS Vikrant. About a year and a half ago, our Honorable Prime Minister dedicated this mammoth engineering manifestation to the nation. And all of you know that this is the largest ship ever built in the maritime history of India, but it had an indigenous content of almost 76%. So it has state-of-the-art automation features. There are 14 decks with 2,300 compartments, which can carry around 1,500 C values. So if you look at the major technical highlights, it has something called a stow bar, which is like a short takeoff and arrested recovery. And the entire ship is powered by 8 generators, which can sort of light up a city of 2 million people. So it's actually a floating city with 14 floors and a 16-bed hospital. So there are big flight decks the size of 2 football fields, and it can carry around 30 total aircrafts. Now the thing is, even in such an what do you call mammoth engineering or electrical electronics technology amalgamation, there is enough amount of automation where we have applications of digital technologies. I mean, if you look at, for example, the heart of the system, which is basically the integrated platform management system. This is the command and control center. So it is the most complex system on board. It's actually the brain of the vessel. So what it actually does is it actually unifies all the digital computational control complexes. So everything that is to do with propulsion, with all the electrical systems, with the the ventilation and air conditioning, all the auxiliary systems, the damage control system, everything is actually controlled from a single point, which is actually as an integrated solution. Similarly, when you look at, so this is one end of the spectrum. When you come to the other end of the spectrum, you have even things like, visitor management, which are automated. So the e-visitor book, it is called as Atithi in the ship. It actually has what you call tool which can identify handwriting, it can, and accordingly it can, decipher it into text and, what you call store it. And it can also store these photos of people, visitors when the moment they enter the ship. And these photos will be displayed, even earlier visit photos will be, displayed at various, locations on the ship. So there is no internet because, when the ship is away, it is when it's sailing, you probably don't have access to internet, but then there is a local intranet there. And all this thing has been actually developed. What makes it more interesting is this has been developed by students of a private engineering college in Kerala. Another interesting aspect is even, the food part, the kitchen in the ship, we call them galleys. They are also automated. So there are 3 galleys in the ship, and they actually produce 5,000 meals per day, catering to 1,500 to 1,700 people. And these galleys are automated, and they churn out something like 16,000 chapatis and 6,000 idlis, just to give you an example. So what exactly are digital technologies? So when we talk about digital technologies, we're essentially talking about electronic tools or devices or systems or even resources which can generate, store, and process data. And they are actually into the heart of ensuring the smart engineering. So we talk about the what do you call it, the methods, the process, and IT tools, which are for interdisciplinary system-oriented development of innovative, intelligent, and network products, or it could be even production plans and infrastructures. So the comprehensive exchange of information between all components plays a major and decisive role, and that is what is ensured by digital technology. And an equally important sub-area is an interdisciplinary life cycle management to improve the knowledge domains and interactions that have so far largely been insufficiently linked, and thus to counteract a continuous loss of information and experience. When we talk of digital technology, one of the major aspects that is very important here is the Internet of Things, which are basically IoT, which has been what do you call the key thing in the last few years. And IoT devices are today bringing new and exciting possibilities into our lives. When everything, right from changing how we commute to illuminating the way the world looks around us. And at first our only concern was whether about the simple things that devices did, and like a digital display showing statuses and digital input enabling us to configure them. But now devices can talk among themselves, and they can also talk to their the manufacturer or the maker over the cloud, and enabling real-time insight. So we can see this occurring in personal devices as well as industrial machines on the factory floor. So modern devices are instrumented, intelligent, and interconnected. They can transmit and accumulate data and then use it to improve their performance. The tremendous functional possibilities for such products offer both opportunities and also challenges. So in a way, application of digital technologies enable 2 important things, that is, connectivity and sustainability. So in an urban setting, for example, when we talk of city life, many of our cities are now smart cities. They are infused with the gamut of digital technologies. So everything to do in the city, whether it is buildings or safety or parking, everything is now smart. So when we talk of, let's say, smart parking, so there are chatbots, where which you can ask these chatbots to, about information about, the closest parking site, and it even shows you the live view of available spots. and then the opportunities for charging if you have an electric car, for example. And even if you go to a mall today, like it will tell you which location has vacant spots, how many of them. The entire payment system is automated, eliminating the what do you call the middle ground for human operators. And when we talk about smart lighting, there are dashboards which show that using smart lighting, you only turn on those street lights that are needed. So you save lots of energy. When you talk about smart safety, for example, when a car or person is standing on the railroad and where it's not supposed to be there, then the smart cameras detect them and immediately alert an audio, which is played automatically, alerting the car or the person. Similarly, when you talk of smart buildings, measuring a range of environmental conditions help to ensure that the office layout is optimized. It can boost productivity also. A dedicated device could probably check all the main values of air quality, temperature, humidity, and information related to pollution, etc. And you can also request the chatbot to give you this information. So on and so forth. So what I'll do in the next few slides is to give you practical examples of how many of these have actually been implemented in different cities across the world, as well as some of them in India as well. So let's start with waste management. So one of the first cities in the world to implement a truck-free waste management system is actually Songdo in South Korea. So the city achieved this thing by installing bins which are connected to a series of underground pneumatic waste pipes that transport these trash to a waste processing facility, where the waste is automatically sorted and either recycled, buried, or burned for energy. So these pipes connect all the apartment buildings and offices. So therefore, there are no street corner trash cans or garbage trucks, which means that you won't find garbage piling up anywhere outside. And the Songdo system was also the first to eliminate the need for collection trucks by connecting every building in the city to the underground pipe system. So this waste management system in the city is called the third zone automated waste collection plan. So this not only cut down on carbon emissions because of eliminating the trucks, but also it saved the city a lot of money. And it was said that by 2014, the city had required only 7 workers in entirety to operate the system for the entire city. Another example of the smart waste management is in Netherlands. So Amsterdam, the capital, is well known as one of the most eco-conscious cities in the world. And as part of its goal to reduce carbon dioxide emissions by 95% by 2050, the city set out to upgrade its public waste collection system with smart technology. So in 2014, the city added weighing mechanisms to some of its collection trucks and installed fill level sensors in public trash bins. So it used this data to create more efficient, cost-effective waste collection schedules. They also introduced this concept of waste streams in 2020, which is proposed to clean up the piles of trash that were lining the historic canals in the city. So this mechanism involves installing floating dumpsters in canals, which can be collected and returned by autonomously operated boats. So again, there's no human intervention. So this system will eliminate the need for curbside trash pickup in historic districts, and it provides a more energy efficient alternative. Another example that I would like to take is from the city where I currently reside in Moscow. So again, there is a huge infusion of digital technologies for managing the traffic. Traffic used to be a nightmare in Moscow. It was told that according to data from the state automobile inspectorate, by the end of the last decade in Moscow metropolitan area, there were 8.4 million cars registered, which is like 1,70,000 vehicles more than the previous year. So they had installed a very interesting system for traffic management way back in 2011. So this is basically they have a traffic control center, which is a powerful technological center, which applies cutting edge information technologies for traffic management. So they have developed something called as an intelligent transport system, which was developed not only to observe the traffic flow in real time, but also to forecast the traffic situation, regulate traffic flows, monitor important transport infrastructure objects, etc. So this system operates 25/7. It controls more than 40,000 traffic lights, 185 information screens, and more than 3,000 photo and video cameras for tracking road rule violations and 3,900 sensors. So they created something called as a digital twin, which is basically an accurate reflection of the city in the digital realm. by which they could analyze the real situation on the roads. So information on the city roads were, from different corners were connected through sensors, collected through sensors and different monitoring systems, and then they were, what you call fused onto this digital twin. So they also had a dynamic transport model which evaluated the real-time traffic situation, making a short-term forecast and informing the residents on a 24/7 basis through targeted SMS and push notifications on their smartphones. Another very interesting thing is they had this initiative called Vehicle to Infrastructure, which is called as V2I. So it's this V2I communication system is a system of wireless connection, allowing vehicles to share data with traffic lights and road signs. For example, using incorporated sensors and detecting devices. So it's an integral part of autonomous vehicle development. And most of all, for a commoner, they have this, mobility as a service, which is basically a multimodal transport application on the mobile phone, where all the transport services in Moscow are unified into a single app. So this transport app, enables users to build multimodal routes, hire taxis, book car sharing, learn about the arrival of buses and trams in real time, and check the loading of public transport. So it's like, if I have to start from home to office, when I use this app, it will tell me, how many steps I need to take from my home to the nearest bus station stand that I need to go, the time in which the next bus will arrive, at what time it will arrive at the metro station, which number metro to take from which platform, which then to get down at which, what you call point to get down, to take a bike, electric bike from there, get to the office, where to drop the bike, etc. Everything, so a single app, and even payment as well. So that is how integrated it is. So in India too, we have been applying, digital technologies in our cities. So the classic cases that of, traffic management at Chandigarh using, artificial intelligence. So there's an integrated command and control center in Chandigarh, the smart city, which is implemented through a PSU. And this has been operational for almost, 2 years now. So they have an adaptive traffic control system called ATCS, which is a key feature of this system. And this has been set up at 40 junctions with the heaviest traffic volume. So the key technologies here are, artificial intelligence and, machine learning, etc. So these traffic lights will work in tandem with road conditions to optimize the flow of traffic. With the help of, smart cameras and, sensors installed by the roadside, the system will monitor individual traffic lanes, number of vehicles, calculate the traffic light duration required to minimize traffic log jams, etc. So this artificial intelligence-based system will reduce the traffic time within the city, and they have reported actual figures as well. They have reduced the waiting time at intersections and also saved a lot of fuel wastage due to idling at intersections. So in addition to the the ATCS as we call it, the system also includes CCTV surveillance, integrated traffic management system, public address system, etc., and also a dynamic message system like we spoke about in Moscow. So this intelligent traffic management system caters to red light violation detection. It also caters to overspeed violation and automatic number plate recognition. These are all integrated actually. So in addition, they also have a public addressing system, and variable message signs have been incorporated at various junctions to disseminate information like traffic alerts, meteorological information, like for example, if there is there's a storm or rain or whatever, so citizens will get that information in real time. And they also incorporated each lane systems, smart parking, public bike sharing, etc., which they are actually planning to integrate in the subsequent phases. Another example where digital technologies have come to the fore is in terms of water management. So for this, I'm taking the case of a city called Denpasar in Indonesia, which is one of the tourist hotspots in its country. So they took efforts to solve the problem of potable water through technology. So the entire provision of clean water from storing, intake, processing, distribution, and monitoring, they used information and communication technology. So the project is based on active non-revenue water management using a zoning system. So the system as a whole is divided into a series of smaller hydraulically isolated subsystems called district meter areas, in which the volume of water loss can be calculated separately. So DMAs, these district meter areas, are further subdivided into areas with pumping systems and those with gravity systems, and then into villages to facilitate the effective and efficient management and control of the project. The existing potable water zones of Denpasar city use deep wells where the quality of water is also excellent. So sharing knowledge is given to regulators, implementers, supervisors, and consumers, and thereby establishing a culture of good water utilization. The use of the latest technology, such as including Internet of Things, remains adapted to local policies to maintain the nation's cultural value. The technology has included, real-time monitoring using flow and pressure meters, which are also equipped with data loggers and asset management of existing pipe networks and consumer communications, etc. So this concept of smart water grid is also being utilized in many other cities. So basically, the smart water grid is an innovative way to monitor water distribution networks. It consists of a two-way real-time network with field sensors, measurement and control devices that remotely and continuously monitor and diagnose problems in the water system. So smart water meters, they can monitor some key parameters such as flow pressure, temperature, quality of the water, consumption, and energy usage. Some of the advantage of using a smart water grid is better understanding and analysis of the water network, leak detection, water conservation, water quality monitoring, and all this coming at a lower cost to the consumer. So implementing a smart water grid technology allows the utility company which implements it to build a complete meter database. So having a detailed meter grid helps in pinpointing the locations of water leaks. The utility companies will discover missing or illegal connections. Also, the companies know the quantity of water being used and lost in the system. So this improves the monitoring of the metering system, which also helps in faster responses to impending failures. So you can sort of forecast failures as well. So there are several projects worldwide which have implemented this technology and seen very promising results. And in India, we have seen this happening in Mumbai, where ITRON has installed meters in the system that has been supplied water to half of the city's residents. And by implementing the smart meters, there was a 50% decrease in water losses, as was reported. The city was able to identify leak locations as well as promote water conservations, besides ensuring a very better quality of water network. Another innovative feat of sustainable engineering is the Changi Airport in Singapore. So you have this concept called Jewel there. This is one of the most beautiful, or probably the beautiful airport in the world, which I have. At least the airports which I have seen so far. So you have a entire 40-meter high rainwater waterfall right in the airport, and so in this huge waterfall, the water is collected and recycled. So they have used a lot of energy efficient materials and infrastructure systems. They have a lush terrace garden, for the green spacing with 200 species of flora and fauna. But then where does digital technology come in? So they have got something called a smart cleaning, which is actually an advanced technology solution. So basically, what they've done is they have gotten a system with security and maintenance with cutting edge precision. So the smart cleaning uses autonomous robots. They use Internet of Things and also a lot of chemical technologies which are integrated into the system. So another interesting fact is this entire concept of Jewel at Changi Airport was built right in the heart of the airport without disrupting the existing operations. So despite its positions in between the terminals 1, 2, and 3, the engineering team worked its magic for 4 years right in the middle of the entire airport's operations. And this was a major feat for the team to continue building out the Jewel without impacting airport operations or affecting the traffic flow to or from the airport. So coming to the systems in India, the first solar-powered railway station in India is actually Guwahati, and this is one of its kind solar plant built in this railway station, which was commissioned way back in 2017. So this is an interactive solar plant which is set up by the railway station. It is a 700 kilowatt plant and is installed over the roof of the station. So this was set up at a cost of around rupees 6.7 crores at the time of installation. And this plant here, along with saving electricity costs, is also likely to lessen the carbon footprint on a huge level. So not only this, there are a lot of other initiatives by our own, the railways, Indian Railways. So we have solar-powered coaches in suburban trains in Delhi already, and the Indian Railways plans to meet 25% of its energy needs through renewable energy by 2025. So already the first set of train coaches have been rolled out with rooftop solar panels that have powered lights, fans, and information display systems inside. The coaches are used for suburban transit, not only in Delhi but in other cities as well now. And the railways estimate that each train with 6 solar-powered coaches could save around 21 liters of diesel every year, which is worth around rupees 12 lakh. So many other railway stations in small cities across the country, like for example, Trivandrum, Mangalore, and Jaipur, are also partially powered by both solar and wind energy. And the Indian Railways, aims to become a net zero carbon emitter by the year 2030, and it will be the world's largest 100% electrified rail transport system by then, hopefully.
So, Mr. Aziz, sorry to interrupt, but if you can wrap up, so we are pressed for time. So.
Yeah. This is just, I mean, I'm the last example actually. Yeah.
Okay, thank you so much.
So basically, the last example that I would like to take is about, again, talking about airports. The first fully solar powered airport in the world is actually here in India, again in Kochi. So they have, they're the first airport to be fully powered by solar energy. So huge power bills prompted the airport to build this 12 megawatt solar plant, which is more than 46,000 solar panels. So they plan generation of another 6.5 megawatt on land and another 7 megawatt through panels to be installed over 3 kilometer long irrigation canal. So the total capacity is like 26.5 megawatt. So they got they were the first airport in the world to actually receive this Champions of the Earth award from the United Nations. So this solar plant eliminates 3 lakh metric tons of carbon, a sum that is equivalent of planting 3 million trees. So that's it. That is how this airport has been progressing. So to conclude, I would like to say that it has been indeed gratifying to see that many engineers across the globe are working to meet the sustainable development goals of the United Nations. So these include startups as well, which are focused on innovations to solve daily world problems. So every day, new startups and technologies emerge that advance the UN SDGs. So these solutions span a range of applications across industries such as energy, healthcare, smart cities, mobility, and Industry 4.0. Most of these startups and scale-ups are aligned to multiple SDGs as the goals are connected to each other. So together, they improve the quality of life around the world by addressing topics like hunger, justice, economic growth, and poverty. Moreover, they accelerate the transition to sustainability, helping individuals and companies and cities as well to lower their carbon footprint for a carbon negative future. Now, this slide particularly shows the top startups as found from a credible survey in 2021, which are progressing these SDGs. And you can also see an Indian startup here called Let's Endorse, which is targeting the 17th SDG. So basically, they are using the digital marketplace and social network for social developments aligned with the SDGs. So they have social multi-stakeholder technology platforms and tools which enable operational and financial effectiveness and provide transparency in the process of bringing change. So it's possible that by the infusion of more digital technologies, we will be able to attain many of these sustainable development goals in the future. So with that positive note, let me end my lecture, and back to you. I mean, if there are any questions, I'll be happy to take. So once again, thank you all.
So thank you, Mr. Aziz. It's a wonderful presentation about the smart technologies for governance and smart cities. So we may have time for one question.
Yeah, hi. Yeah, good afternoon, sir. I have a question. There is one. Okay. So carbon credit. I heard about carbon credit and carbon trading is there. So it's really happening, or it's in the in the planning stage now?
No, it is the carbon credit is definitely there. Actually, in fact, there are a few systems across the world where you get carbon credits for the processes that you use actually. So even for example, in Moscow, like we have a system where the lower the number of flights that you take, you get more carbon credits. So if you use better means of transportation, similarly, if you don't use your own car, for example, and take the public transportation system, and if you take electrical systems, for example, that manner, you get better credit. So there are, and I've heard of some of my colleagues talking about a similar system in Canada as well. So these are definitely things which are happening. I mean, again, it's
really
it's interesting to note that
yeah, it's really happening between the carbon. Like oil and gas and other petroleum companies, or it's in the talk currently planning phase.
It is happening because the very point that we have to really notice, it is not just about petroleum and gas companies. As I said in my first slide, it is about the sustainability and new design are it's a debate. So sometimes, like for example, we have been talking about electric cars now. Now the biggest problem that people are raising is electrical cars. Where do these batteries end up in? So are we going to have a what you call landfill using electrical batteries, which are going to create another problem? So it is so that's an active area of study. But nevertheless, for the fossil fuel energy that we are currently using, carbon energy credit has been a norm, and it is being implemented in certain countries for sure.
Thank you. Thank you.
Thank you so much, Mr. Sameer, for joining us from Russia, and we hope to see you in future also, coming to IIT Kharagpur and interacting with your because this is your alma mater also. So thank you so much. Okay, so our next presentation is from GAIL, Dr. TP Yuvraj, and GAIL is also the diamond sponsor for this conference. So I will request Professor Janamani to introduce Dr. TP Yuvraj.
Good afternoon, everyone. Let me have the privilege of introducing Dr. Yuvraj. Dr. Yuvraj TP is a Deputy General Manager at GAIL India Limited. He is a PhD from Indian Institute of Technology, Delhi. He has extensive experience in natural gas and LPG pipeline line operations, maintenance, gas metering and commissioning, pipeline project management, quality management, Six Sigma auditing are special skills he has built over past 16 years. His specific hands-on experience includes PLC, SCADA, analytical instruments, various field instruments, electrical switch gears, cathodic protection, etc. So I request sir to share his experience. Thank you, sir.
So, good afternoon to one and all. My presentation will be short, and I will not take more than 15 minutes of your time, but I will make it interesting in the sense that this talk will primarily focus on research challenges and the challenges we face in gas industry, and there is a lot of scope for research. So when I talk about research opportunities, I will cover 4 case studies, very short case studies, which we have been doing currently, and there is some challenges in that, and there is a scope for research. And at the end of my presentation, I will put a small open challenge to the audience over here and listening on the online platform. So you can think that, take it up challenge whoever is interested, and GAIL will be ready to work with any of you sitting here. So with that notes, so this is a very well known industrial revolution chart, right from revolution 1.0 started 1780, and we are somewhere in 4.0. So already 5.0 industrial revolution framework is done, and the way forward is already framed up, and but if you see the transition, there is no much transition. There are some advantages in 5.0, but if you see what we are really talking about in 4.0 is all IIoT, industrial IoT, robotics, wireless and smart, and data analytics and AI for machine failures and machine to machine communications. But if you talk about in reality, we are just used 5 to 10% of 4.0. So this is the reality in India. I am talking about in India. This is an Indian context. So already 5.0 is there framework. We are not utilized 4.0 or implemented 4.0. So you can understand there is a lot of challenges in technology wise. We do not have the technology to completely implement all these things in industrial perspective. So, we have a long way to go. So, I will talk this point in terms of gas industry. So, what is the challenges in implementing these some of these technologies? Particularly, I will talk a little bit about data analytics and AI in gas industries, and a little bit about IoT and robotics, right. So, yes, a little bit introduction is required on GAIL's business scenario, particularly the transportation sector. So, this slide is talking about the presence of gas pipeline all over the country, the blue line, right. Can someone switch off this light so that it can be more clear? Yeah. So, the this portion is under construction, right, the dotted ones. Some of them are recently got commissioned. So, the number of the total length of pipeline in operation, gas pipeline in operation is around 16,000 kilometers. So, another 2,000 to 3,000 kilometers will be commissioned in next 2 years. So, and all these pipelines are underground. They are buried under the the normal ground level at the depth of 1 to 1.5 meters, and we have an big challenge of safeguarding this particular right of way. We call it as ROW, or right of use, that is the ground which is above the pipeline. So, that route has to be clear of all type of intrusions, buildings, permanent structures, or any third party activities like excavation or road laying and other stuff. So, we have to have a very stringent and foolproof surveillance mechanism to ensure that there is no such type of activities over the pipeline. So, that is the biggest challenge, and that is not in our control. These lands are owned by somebody else. So, we have only the rights to use the land, we are not the owners of the land. So, the entire 16,000 kilometers we have to monitor on daily basis and on continuous basis. So, that is a challenge. So, next few slides I will talk about what are the things we are targeting to monitor this gas pipeline ROU. So, we are targeting to develop an unmanned aerial system which can do the surveillance as and when we require and ensure that the pipeline ROW is free of all these third party intrusions. So, along with one of the premium IIT, we started working on this since last 4 years, and we are targeting to for pipeline ROE surveillance, also gas leak detection. So, we have another challenge of detecting the leaks in the pipeline in the real time scenario or at the earliest time frame. There is a leak happened at 10 o'clock in the morning, we should know at 10:01 minute, we should able to know where is the leak, how much is the leak, and the next course corrective action can be taken. So, there is a requirement for both surveillance as a gas leak detection. So, we have developed 4 prototypes with the features of vertical takeoff and landing capability and an important aspect of autopiloting. So, we give a coordinates from start point to end point along a pipeline, say for example 100 kilometers, from 0 to 100 kilometer it has to navigate without any manual intervention, and it should do a continuous video recording. So, that is what the surveillance is all about, and the real time streaming of this video to the ground station or to the operator's control room. So, this UAV is capable of handling 4 kg payload, and the trial show that it is capable of non-stop travel from one place to another up to 40 kilometers. So, we are targeting more than that, but at present 40 kilometers is very good endurance, because our gas stations are built at the interval of every 25 to 30 kilometers. So, we can hop from one station to another, recharge the battery or replace the battery and fly for next 30-40 kilometers. So, this is just an parameters and the specifications of this the entire UAV we have built. I am not going into the details of the because of the time constraint, just a few things. Propulsion is brushless DC motor, it is electrically driven with the battery power. So, it is a noiseless, that is the basic part. If you put a gasoline engine or a diesel engine, it will be more noisy and it have more vibrations when it is flying. So, it is electrical motor driven, and there are two cameras. One is the video camera, and we have one more gas sensing camera built in the built along with the UAV, which can do the both leak detection and the surveillance. So, these are the photographs of the 4 prototypes. The first one was built with high density foam, right, and next is which weighted about 12 kg, and we came up with the next better model. This is a glass fiber reinforced plastic, and which is having even a lesser. So, it came down to 6 kg weight, half the weight. Then we gone for a very high strength reliable composite material, that is carbon fiber with the overall MTOW was 11 kg. Then we had some issues with this model, then we have gone for the carbon fiber plus high density foam. This is the final prototype. We have the video camera and the natural gas sensing camera, which is sitting on the belly of the UAV. So, this is photographs, and we have filed a patent on this particular model, and it is under review. So, what are the challenges in this development? 50% of the components in UAV is imported. So, we say that we are just assembling it, and many things are coming outside the country, and the one of the major component of this imported item is the gas sensing camera. See, so is this creating the noise? Okay, fine. So, the cost of this camera is 73 lakhs, only one camera. So, we have in and out searched throughout the globe. Very few vendors are there who are making this camera exactly matching the requirements of gas industries. So, it is one of the biggest challenge to indigenously manufacture such cameras within the country, and there is going to be a huge demand for this particular sector. So, and manufacturing prototypes. So, we have now built a prototype. Now, how to manufacture in 100 numbers. So, there are very few people manufacturing composite framework for the UAVs. So, there is this is another challenge. So, these challenges I am putting forward to this audience, that many of you academics can think it of, like how to build a gas camera within the country. I will come to this in the later stage. What are the intricacies in building up the gas camera? It is going to be a interdisciplinary research work, right. So, I will just quickly move to the next part. This is another segment, another route to monitor the gas pipeline, that is through satellite images. So, you take a pictures from the satellite of your entire pipeline ROU, monitor it on regular basis and see whether any changes are not, and take a corrective action. So, you have a flying mission earlier, now you have something sitting 20,000 meters away or 20 kilometers away, and take some periodically images and see what are the changes. So, we are trying to develop the auto change detection software using artificial intelligence with the help of the base satellite images, because the images are nothing but the data, right. So, what you do with the data, you have to interpret whether some changes are not without any human intervention. So, there comes the artificial intelligence. So, we are trying to develop this software with the help of our collaborating IIT. So, we have taken a typical pipeline in Uttarakhand, northern region of country, from Saharanpur to Haridwar, 64 kilometers of pipeline, and we studied the satellite images of this section and try to develop a software with a unsupervised AI model. It is basically a classification type of software which can do land what you call the the land profile analysis and see whether any changes or not by comparing the previous image with the current image. So, this is all about the auto chain deduction. So, we have to purchase lot of satellite images from the foreign vendors and do the and validation of software is under progress. Software is built, we have to validate it. So, how we validate it? Put a real time changes or artificial changes and try to see whether it is able to detect the changes or not. So, these are some of the parameters attributes we are used in the algorithm, like water. Water means stagnant or running. It is a lake or a river. If it is a built up area, it is a road or building or something else. So, agriculture we have a different type of agricultural, whether it is a cultivator, sugar cane, wheat. So, all these parameters have been brought into the software, so that there is a change, the software will tell there is a change of a particular type. So, this is a typical image that pipeline is running like this. So, these are the colors the software has predicted from the real images and try to classify it whether it is a grassland or a buildings based upon the color codes and the pixels, right. So, the upper one is December 31st, 2021, and after 3 months we have taken a second image and try to compare it. See, there is a change in the same location. This is the same location, you can see. So, there is a lot of changes. So, this change software will analyze and give a useful information to the gas operators to see whether any action is required or not. So, these are the satellite images of a particular location. If it is a zoomed way, you can say there is a buildings here which is very near to the gas pipelines. So, there is again a challenge here that we have a 2D images from the satellite. So, 2-dimensional means when you see from the top any object, it have a x and y axis. So, there is no depth or the height data. So, that is a challenge here. So, we have to do a different technique called interferometric analysis using the 2D imaging only to arrive the depth parameter. So, very people have reported this particular technique to arrive at the classification. If you see a image from the top of a building, it looks like a simple rectangular box. It can be a bus standing on the road. It will, when you see a bus on the top of the top section, it will be looking at a rectangle. If you see a building, it will be rectangle. So, how do you define or classify which is a bus or a building? So, that is the challenge. So, unless you know the depth and the side view. So, either we have to tilt the satellites at a certain angle to infer the depth. So, you have a what do you call the different types of satellites in the geostationary, also polar satellites. The polar satellites will move from north to south. So, you have to tilt the camera from the 20 kilometers away and you have to take the angular images. So, it is all complicated, but it is doable. So, this challenges is being now addressed in our current research. Third approach is fiber optics based intrusion and leak detection. So, intrusion here I am saying is the intrusions are third party activities happening above the ground, above the gas pipeline segments. So, here these optical fibers are laid along with the gas pipeline in the same trench. So, that means you have an infrastructure available along with the pipeline of entire 16,000 kilometers, we have a parallel 16,000 kilometers of optical fiber. So, how can we use the existing infrastructure to detect your intrusions as well as the leak? So, this is another good work we have undertaken with one of the premium IITs. So, we are using two technologies here, distributed fiber sensing as well as the distributed temperature sensing. So, these two technologies uses the laser light which is going inside the optical fibers, and any perturbations, any activities happening on the ground level can be captured as a sensors with the this fiber distributed fiber sensing is including acoustic sensing and temperature sensing. So, though
when you have some vibration activities, this acoustics generated. So these acoustics are captured by the laser which is passing through the fibers from one place to another, and it is backscattered. So you get a backscattered signatures when you have some perturbations. So these backscattered signatures have the information of what type of perturbation it is. So we have to analyze these backscattered signatures and try to see what type of anomalies we are facing. And temperature is primarily used for distributed temperature is primarily used for leak detection. So if there is a leak from the gas, there is a temperature drop in near and out on the pipeline in the soil conditions. So the temperature change can be detected easily with the help of distributed fiber sensing. So this technology we are validating with 100-meter long pipeline test bed in one of the IITs, and we are literally laying a optical fiber and testing it rigorously with various type of intrusions and leaks. So there is again a requirement of data analytics here. Why data analytics? There will be lot of signatures coming out from the intrusions and the simulation work. So we need to make a classification model to classify what type of intrusion it is by building by bringing in the artificial intelligence. So this is the work going on. So ongoing project. So the first prototype is ready. This is a 19-inch by 17-inch rack mounted module where entire optics and your electronics, entire thing is sitting inside it. You have to just plug the one end of the fiber, optical fiber, and you will start analyzing the optical signatures. So this is a 50 kilometers optical fiber cable which will be connected with this the box which I have developed prototype, and the entire 50 kilometers can be tested at one go. So the laser will start from 0th kilometer, 50 kilometer, and whatever perturbations you are going to give on this, so it of course it will be buried underground along with the small pipe, and we will undergo a lot of testing and validate this particular technology. So the challenge what is we are facing is the signatures. Now the signatures something looks like this. So can you make out anything out of this? What type of intrusions, what type of issues are happening? So it's very difficult. So these type of images needs to be scanned, analyzed using some sophisticated software. So that is what we are trying to use ML based classification to both do the raw optical signature and water plot. So this type of plots are nothing but we call it as water plot signature data. It looks like a water flowing like that. So its signatures also looks like something like that. So the another challenge is the scarcity of reported data. So we have few commercial vendors who has developed this technology abroad. They are not sharing any of the data, particularly the optical raw signature. That is the bread and butter for their commercial product. So we have not got any data, even though we have purchased 2 systems from the commercial manufacturer and using in our pipelines. They never share the data what is inside that black box. So we are spending for one technology 3 to 4 crores for 50 kilometers of pipeline. So we have to cover 16,000 kilometers of pipeline. So you can imagine how much money we have to spend on imported technology. So this is a indigenization targeted project to have our own technology for our own use. So I will take next 5 minutes to wrap up. This is the 4th one which I am talking about. This we are doing with Industrial Systems Engineering Department of IIT Kharagpur as well as Electrical Department of IIT Kharagpur. So we are trying to do shifting from slightly to pipelines to process industry. So we have a process setup where electrical motors are being installed for driving the loads. So how to monitor the failures before it is happening. So this is very important to avoid the breakdowns and non-availability of the machines. So we have been doing this project for last 3 years, and our target is using the single current sensor how to diagnose the the failures before it is happening. So, some of the things like we have already developed the hardware, and the software is developed to simulate the faults. 6 different faults have been simulated and experimentally validated, and this machine learning part is developed to a larger extent, and training and validation is still under progress. So, we have collected lot of real time data from the actual motors from the Gale's process plant. So, with that data we are trying to simulate the machine learning software. So, here the challenge is some of the historical data, the old data are not available in the form of digital formats. So, they are handwritten, like 10 years back there is no SCADA, there is no sophisticated control systems. Many things where we are not able to trace out what went wrong, what failure was happened, and there is no proper records to simulate this. So, we are trying to gather more data from the other sites, and of course, this thing is under progress. We are going to catch up on the machine learning based remaining useful life prediction. So, this is the last part of the presentation. It will take 1 minute more or 2 minutes maximum, and this is the open challenge topic which anybody is interested can work on this. And the background of this challenge is we have a issue of gas leak detection, which we have addressed something in our older slides, putting some cameras with the UAV, and fiber optics cable can do some sort of sensing. But what about in a closed environment or the process plant where there is a leak in the pipes, right, in the above ground pipes, not in the underground. Now, we have above ground pipes where leaks tend to happen in the joints, flanges, and other critical equipments. So, so this photograph is talking about the above ground pipings where handheld gas sensors have been used to identify any leaks or not. So, this type of sensors are mounted in a particular location near the critical equipments to see whether leaks are there in a confined environment. But the problem is we have such complex networks of pipes. So, how many sensors we need to put? N number of. So, what is the cost implication? Safety is required, but cost is also enormous. So, the problem is, I will just run a small video, you will understand what is the intricacy of this problem. Just have to click it on the video. I hope it takes it. No? Yeah. I can run from Google. The same thing happened in the morning. I can run. इसको इधर कॉपी कर देना. One second. Yeah, small audio. नहीं जरूरत नहीं. तो ये ओपन क्यों नहीं हो रहा? हाँ, एक मिनट मैं इसको करता हूँ. हाँ, skip. Yes. I think you can. Yeah, you start from here. Full screen. So, you can see here, this is actually the gas camera pictures coming out. So, not the visual pictures. So, these fumes you can see, they are not just some smoke or something coming out. They are actually natural gas getting leaked out, which is seen by the sophisticated cameras. So, FLIR is one company in the world who have built this camera for gas industries. So, yeah, just to show. So, this is coming from one of the plant on the roof. They have some piping inside it. There is a leak. So, it is coming from the roof of the pipeline, roof of the industry, gas industry. So, this is not actually visible to the eye, normal human eye. So, that is a problem. These gases are odorless, do not have a smell, and they cannot be seen in the visual eyes. So, that is the problem with this gas, and we need to So इसको बंद कर देंगे. दो है क्या? So this is a challenge, and very few companies are doing this commercially developed this product. So the challenge is, why can't we develop a more sophisticated equipment like this, say a gas goggle. So you put a gas goggle like this, which is able to see the natural gas leak in any environment like gas industries, and the operator can easily attend the problem of leakages as and when he sees there is a leakage, right. So this is a beautiful product which is not there anywhere in the world. We are expecting that such product is a requirement in gas industry, for which there is a real R&D is required. Who can be the team members? Material scientist, a physics and optical engineering background, electronics engineering, instrumentation and control, and a computer science. So if there is a interdisciplinary research, such things can be possible, and this is a product a gas industry requires. So with this note, how can we do this? We have some collaborations, of course. So these are the current R&D collaborations, but this is my last slide. So when you have to develop something from TRL level 1, which is an idea stage, to up to TRL 9, it has to go from knowledge development, technology development, business development. Here IIT comes into play at least up to TRL 3. So when you demonstrate a prototype up to TRL 3, then there can be a collaboration from industry. Industry can handhold it to TRL 9, but there has to be some partners in between. It can be a private companies or a CSIR lab which can move from TRL 3 to TRL 9. Of course, gas industry will be the end consumer and will be the customers. So this model we are trying to work it on for many technologies, including this type of technologies, because we know the limitations of IITs. We know up to what level they can go. So this model is best suited for this type of high intensive disruptive technology development. So with this, thank you very much for your patience listening. So any questions, I am ready to take.
So thank you so much, Dr. Yuvraj, for the wonderful presentations, and this really gives us some idea about the research problem. So I will open for questions. So, yeah.
Hi, Dr. Yuvraj. So I have two questions. My first question is for the satellite imaging. Have you all done multispectral, hyperspectral kind of analysis of the thing? So wanted to know more on that solution.
So we have taken two spectrum of images. One is the optical data, which is targeting 400 to 700 nanometers RYB, having the visual colors of what we see, and also radar signatures. So radar signatures has the capability to penetrate through the clouds. So if there is a cloudy weather, so radar can pass through it. So during some worst situations, we get the images still even there is a cloud form. So we are getting both the things and try to see the objects and the ground level. So we are taking two spectrums.
Okay, and the other one is about your challenge, the gas goggle. So is it like it is something that will be developed so that when the person wears it, they will be able to see. But what about when that person is like so I am assuming that the person who is manning the gas line is supposed to expected to wear it all the time. Like, can that person see otherwise, or is it like a AR type of goggle which you only wear to inspect and means to do whatever, and then in 15-20 minutes you take it off?
So that's a good question. So typically environment like process industries where there is a lot of pipelines. So there is a lot of pipings and other stuffs. You have equipments. There is a tendency of leakage, right? We don't know where is the leakage is. So once in a while we have shifts like morning shift, evening shift, and night shift. So once in a while the process engineer or the technicians has to go for a regular inspection of these type of leakages. So it's typically once in a shift you have this goggle, just to go and walk around, and this is capable to see up to 50-100 meters, not in the range of few meters. Oh, yeah. So that is the advantage, that this can have a large view, and the optical angle, the visual angle is also very large. So the once in a shift, it's just go and monitor what is happening. If there is a leak, take corrective action immediately. So this is the type of maintenance we do. Yes. So here there are two types of cameras available. The one which I have showed as a video is actually using the infrared cameras. So infrared, why? Natural gas is having 90% methane. So methane, if you check the absorption and emission levels of the methane molecules, it is good at 1550 nanometers and 3300 nanometers. So these two wavelengths are good for detecting the methane gas. So they are predominantly are more effective in capturing the leakages. If there is an
intensity variations, the images.
Yeah.
Then what would you do? There are intensity variations in the image.
It doesn't matter, right? You have seen the video, right? There is a tanks there, physical objects there, but you can see clearly the flumes, right? So even there is the intensity, you still visualize the leakage. This is one thing. This is possible in infrared cameras. What happens with thermal cameras is that you need to have a temperature difference to analyze it. Even there is a leakage, if the ambient temperature is almost the same temperature of the flue, the gas which is leaking, you will not able to see the leakage. So that is the problem with thermal cameras.
So thank you so much, Dr. Yuvraj, and I myself have a few questions too, but I will restrict myself. I will take it offline. So I would request Professor Jeremini to come and present Dr. Yuvraj with a small gift of gratitude from our department. So please. So thank you so much, and our next track sessions are going to be starting soon, and thank you all for your patience, and now you can go and have lunch if something is left there. But anyway, so thank you so much.